Sir, good morning. Ketan sir. Sir, good morning.
गुड मॉर्निंग. गुड मॉर्निंग.
सर आवाज आ रही सर? सर गुड मॉर्निंग.
आ रही बिल्कुल.
हाँ सर. Dr. Sunil.
Yes, Ajay ji, I'm here.
So it's already we are in the time because sir has to leave at 11.
Okay.
So I think we can start. So very good morning to everyone. And as we are aware, like this is the part of Madhya Pradesh Vigyan Sammelan. Madhya Pradesh Vigyan Sammelan, we are having 17 different conferences and 3 conclave. So this is one of the event. This is dedicated for renewable energy. And we already have the inaugural session on yesterday evening. And I hope most of the participants had joined this. And today morning, we are again having a very well-known personality, Professor Chaitanya Solanki with us, and who is known for his solar initiative. So, sir, very good morning from behalf of our MPVS team and our organizing team. Sir, good morning. And
Good morning.
now I request Dr. Sunil to please officially introduce Professor Solanki, and then we can start the event. Dr. Sunil, please.
Okay, so very good morning, everyone. So most of you, I believe, know Professor Solanki already. Even in the pre-event session, we had a bit of discussion. Unfortunately, Professor Solanki was busy, and but still he talked for, I think, 20-30 minutes during his visit. I mean, during his cargo journey itself. So just to give a brief introduction about the Professor Solanki. So Professor Solanki, as of now, is a professor in the Department of Energy Sciences and Engineering at IIT Bombay. He has received his MTech degree from IIT Bombay and doctoral degree from Inter University Microelectronics Center at Belgium in 2004. So Professor Solanki has been awarded with many prestigious awards such as European Materials Research Society Young Scientist Award, and in 2009 he was awarded the Young Investigator Award at IIT Bombay. So Professor Solanki has been working in the field of solar energy for several years now. I think he has more than 20 plus years of experience in renewable energy sector. So Professor Solanki has also authored over 100 research articles as well as 4 books. And he is continuously working in developing frameworks and the implementation of the solar intervention to ensure the abundant clean energy in rural areas of our country. His focus is on developing sustainable and localized solar ecosystem. So I think Professor Solanki is going to talk about today on the topic of energy, climate change, and energy Swaraj, if I'm not wrong. So without further delay, I would invite Professor Solanki to give his talk. Thank you very much.
All right, so good morning, everyone. Just 1 minute. So good morning once again, everyone. It is my pleasure to be with you. Unfortunately, not in person, but at least through the e-media. And thank you very much for inviting me here. I remember last time when I discussed, I was in a car moving and I was in Delhi. So I'm going to speak for about 35 minutes or so. Another meeting at 11:15. So let me share my presentation. Great. I hope you are able to see my screen now. Yeah. So once again, good morning to everyone watching this. I'm going to talk to you about energy, climate change, and how they are correlated, and how energy Swaraj or the locally self-sufficiency in terms of energy can solve this problem? Well, I always would like to point out to people that let us realize that we are the most modern humans, most evolved species ever existed on this planet. Never ever before in the history of the planet, there have been species which are so evolved as we are today. We are scientifically advanced, technologically advanced, economically advanced. We are so advanced that, in the times of Ramayana and Mahabharata, only few people had the vision to, see beyond. Like in Mahabharata, Sanjay had the vision to see beyond and see what is happening in the warfield. But today, all of us have the WhatsApp video call. We can make this video call. We can make and see anywhere what is happening in the world. So look at the enormous progress that we have made, and also look at the power of the humans today. We have become so strong, so powerful that we can actually change the direction of the planet and the life on the planet itself. And therefore, when we are so powerful, it is important to become philosophical. And as Plato mentioned in his book Republic, that every king should be a philosopher, or only philosopher should become a king. So it's very important to be a philosophical, and without philosophy, by the way, I believe the modern humans are like headless chickens, and they do not know where to go, which direction to go, and all. And that is exactly what what is happening right now. So my first philosophical question is, how are you all? And typically the answer that people give is, I'm fine, I'm okay. And everybody, 90% people will actually reply saying, I'm fine, okay. But the fact of matter is that we are not working so hard just to be fine or just to be okay. We work so hard to be happy. So in fact, everybody who's attending my lecture, I put that condition compulsory that you have to be, jabardasti happy during this next 30 minutes. Even if you are not happy, and those who are not happy or cannot afford to be happy, don't attend my talks. That's a condition that I put. But that also is a fact that what is happening. GDP is increasing, and it is ever increasing. It is increasing with 5%, 6%, 7%, 8%. But every time GDP increases, the whole purpose is to increase prosperity. But that should result in increase in smile on the people's face. Whenever GDP increases by 5%, shouldn't the smile also increase by 5%? But that's not happening. What is happening? Smiles are decreasing. Pensions are increasing. Violence is increasing. Depression is increasing. So to me, it looks like there is something wrong in this world. There is something wrong in this world. How it is possible that with the GDP increase, smiles are decreasing? My second philosophical question is, what is important, the most important thing in your life? What people say? They say parents are important, children important, job important, health important, happiness important, this important, that important. Nobody tells me that air is important until unless I ask people, close your nose for 1 minute. Just 1 minute, close your nose, and you realize the most important thing in your life is not job and this and that, but the air. You can't breathe. You can't live or survive without air more than a minute. And if that is the case, we should be doing something to protect the air. Are we doing anything? No. People hardly do anything to protect the air. Even it is so important that we can't live more than a minute. So are we doing something to pollute the air? Answer is yes. Everybody is working hard to do that, isn't it? Water, we can't live without water for more than 3-4 days. But are we doing something to protect the water, conserve the water, purify the water? No. Even the holiest of the holy river like Ganga, Yamuna is also become polluted. So water is also getting polluted. So what is happening is GDP is increasing, but on the contrary, the nature is degrading. The life supporting element, air, water, food, soil, river, all those things are degrading. And therefore, let us realize that there is something wrong in this world. Something wrong. We are missing something in a very, very big way. And I think that's very important to understand. So all the elements of nature, which are life supporting. We can live without mobile phone. We can live without TV. Even we can live without clothing and home, but we cannot live without water, air, and soil. So these are very, very important dimensions of our life, which you are not following. So air quality index is bad, forests have been degrading, water scarcity is increasing, soil has been degraded to 33%. So basically all these elements are going down. And the next question is, what has driven us to this state? Why in such a bad state? What has driven us? Why we have come to this level? And we call ourselves as the most modern species. We are very advanced. And the reason being, when we look carefully, the reason is the use of energy. Because we have been using energy in a manner that we have been using, we have brought, it has come to this level. And use of energy is in a way important because the whole world is a play of energy. Everything around us happens because of energy. Even, in fact, our internal energy that drives our enthusiasm, energy, creativity, that itself is, I think, going down. That's, as a result, smiles are also going down. And the external energy that drives our lights, fans, TV, computer, vehicle, that energy is also in a bad shape. That's why there is a climate change in the world. Therefore, the whole game of energy that is being played on the planet which is very important game. Why? Because all our social and economic growth parameters are dependent on this. So whether it is poverty, hunger, education, gender, equity, industrialization, everything is energy dependent. So these are sustainable development goals 17, and the center of this is energy. So energy access, clean energy access, of sustainable energy access is important. But the problem is that the current energy mix that we have, it is predominantly based on fossil energy, predominantly. Look at what is happening in the last 200 years. On the onset of industrialization, before that, the biomass was our main fuel. Then 1850, we started using some coal. 1900, we started using coal plus some oil. 1950, we started using coal plus oil plus some gas. But 1950 onward, let us look at how fast it has been growing. The problem is that in our energy mix today, the hydro, nuclear, biomass, wind, solar, they are very small portion. Put together only 15%. 85% of our energy today comes from these sources, coal, oil, and gas. 85%. And the problem is that every time you burn this source, and most people do not even aware that even while you are cooking food, you are responsible for climate change. Even we are driving, you are responsible for climate change. So each one of us have been responsible for this particular chemical reaction. Carbon plus oxygen results in energy plus carbon dioxide. So when you are eating food, you are responsible for emitting carbon dioxide. When you are brushing your teeth, you're responsible for emitting carbon dioxide. When you're traveling, you're responsible for CO2 emission. Everything that we do, we are responsible for CO2 emission. And the amount of CO2 emission that we do also, we are not aware. And for the analogy, the garbage that we throw out of our kitchen in the form of vegetable waste and dust and everything is hardly 1-2 kilogram per day, 50-60 kilogram per month. But the garbage in the form of carbon dioxide that we throw in the atmosphere is in the range of 400, 500, 600 kilograms per month, 10 times more. The garbage that we throw out of the kitchen is digestible. 80-90% of gets digested, except the plastic and all, in 4-5 months. The carbon dioxide that we all throw in the atmosphere remains there for 300 years on an average, up to 1,000 years. So how terrible it is, how dangerous it is the modern humans have become today, that we have been pumping carbon dioxide in the air as if it belongs to my father, or as if my grandfather has left me the space in the environment, in the sky, and we can pump any amount of carbon dioxide. And carbon dioxide is a greenhouse gas, isn't it? It's a greenhouse gas. So what is happening is the use of energy today, one day, your electricity consumption, your fuel consumption, your LPG consumption, use of energy today is going to release carbon dioxide in the atmosphere, and this carbon dioxide going to trouble us for 300 years. 300 years. And who is going to bear the burden of 300 years? Of course, those who are the users will die in another 30, 40, 50 years. Those who are going to, be left behind, the children are going to pay for it. And therefore, I think the activity of the humans are actually not only just terrible, but it is a crime that we are doing today. And as a result of the carbon dioxide, life is much higher. We have been pumping and pumping and pumping and pumping. And look at the amount of carbon dioxide that is accumulating in the sky, and it is increasing. So CO2 concentration used to be 280 parts per million. It has gone up to 415 parts per million. There is 45 to 47% extra carbon dioxide, which is resulting in a extra warming of the planet. And extra warming is how much? Is increasing significantly. As of today, as compared to 1880 to 1920 mean global temperature, our temperature is risen by 1.1 degrees centigrade. And if you look at the last 60 months or 12 months alone, you see our temperatures are warmer by almost 2 degree, 1.23 degrees centigrade. That is what is happening on the planet right now. So the planet is warmer by 1.1 degree centigrade or 1.98 degree Fahrenheit. 1.98 degree Fahrenheit is a lot. Our body temperature is 98 degree Fahrenheit. When the temperature increases by 2 degree, it becomes 100 degree, and we call it body has got the fever. And now planet is also 2 degrees Fahrenheit warmer, so we can say planet has got a fever. And when we get a fever, what happens? We lose balance. We cannot work properly. We cannot sleep properly. And similarly, the planet has also lost its balance. It is not same anymore. There are enormous changes in the weather pattern. There are floods everywhere, and everywhere means it's not India, everywhere on the planet. China, Japan, Australia, Europe, India, enormous sizes of the floods, and millions of people are getting displaced. Hundreds of them are also dying because of the unnatural floods, which is not there. There were forest fires of enormous size. We heard of Amazon forest fire, but after that, Australia forest fire, America, then Greece, Italy, Turkey, Russia. These are all major forests of very recent times, last 3-4 months only. The ice is melting with enormous pace. The Arctic ice, which used to be there about 7.5 million square kilometer, has reduced to about 3.5 to 4 million square kilometer. And the habitat of the polar bear is decreasing very fast. There are heat waves of enormous nature in Canada. One of the city has got 9.6 degrees centigrade. 900 plus people died because of the heat waves. Everywhere on the planet, there are heat waves taking place. Sea water is rising at the rate of 3.3 millimeter per second. That's the rate at which sea water is rising. There are many parts of the world, particularly coastal area, is sinking. And the Jakarta is one of the big city, is called sinking city of the planet. Many low-lying islands are actually getting water. One of the major cause of migration of population in Bangladesh is a sea level rise. Storms have increased in terms of numbers, in terms of intensity, and you see more and more storms are taking place. Within India, the eastern coast have faced many storms last year, which were so unheard of. So that is a problem, that the whole planet has lost its balance and things are not normal anymore. And climate scientists tells us that we need to limit our global warming to 1.5 degrees centigrade and maximum 2 degrees centigrade if possible. And what is going to happen at 1.5 degrees centigrade? Will a disaster struck? Will the humanity will disappear from the planet? No, nothing like that will happen. Nature is not going to kill us like that. Nature is going to kill us like a bad villain. There is a dangerous villain in the movies. What they do? How does a villain kill hero? Not like in a one shot, Tadpa ke, aram se. The nature is going to kill us and trouble us, or tadpa ke marne wali. So we need to limit the global warming as soon as possible. We are literally running out of time. 1.5 degrees centigrade. Ideally, we should stop as per the IPCC report. In a very credible body, 180 countries are a member of it. Hundreds of scientists are working for it. So next question is, how much time is left before we touch 1.5 degrees centigrade? Is it 500 years, 200 years, 100 years, 50 years, 20 years, 10 years? No, it depends on how much is our carbon budget left. And the amount of carbon budget left is only 270 gigatons or 270 billion tons for 1.5 degrees centigrade and 1,000 billion tons for 2 degrees centigrade. That looks like a big number, but when you realize that the rate at which we are pumping the CO2 in the atmosphere is very high. How much high? 1.3 million kilograms of carbon dioxide in just 1 second. 1 second, 1.3 million kilograms. And what is 1 second? 1 second, 1 second, 1 second. In this time, in this much time only, we release 1.3 million kilogram of carbon dioxide in the atmosphere. So the time left as per the climate clock is just 7 years and 255 days. There is a 66% chance that this thing will happen. 66% chance. So therefore, literally we are running out of time. And I hope anybody who would like to survive and we would like our generations to survive must act quickly because we are running out of time. But the problem is that we are in a dilemma. And not only in the dilemma, 99% people do not even understand precisely the problem and the nature of the problem. Our politicians, our policymakers are not aware fully. So the problem is we need a growth, and every country is looking for a growth, and developing countries are looking more for a growth. Good, we should. But the growth means we require energy. On the other hand, because 85% of our energy comes from the fossil fuels, every time we want to grow, we are going to contribute to the climate change. So therefore, the problem is one side we need to increase energy supply, on the other side we need to decrease energy supply. How are you going to manage this? Who is going to do that? What policy will require? And therefore, I keep saying that anybody who wants a Nobel Prize, anybody who solves this problem of contradictory requirements should not get a 1 or 2 Nobel Prize. He should get 8 to 10 Nobel Prizes. This is such a big problem. The climate change is not a problem of just changing a climate, change of climate right now. The climate change is a problem of possibility of human extinction from this planet. That is a problem today. And therefore, it is a very, very big problem today. So therefore, anybody who solves the problem should get 8 to 10 Nobel Prizes. I hope some of you from the audience would like to get a Nobel Prize. And if you really want to do it, if you want to get it, the problem is very simple. Just solve this problem. Ensure that the growth happens without contributing to the climate change. Well, what is the solution and what is the approach? The solution is, as per the IPCC, Intergovernmental Panel on Climate Change, we need a drastic and immediate change in the energy use pattern. We need to change, but the change has to be drastic and it has to be immediate. Unless you qualify these two conditions, no action will result in a climate change mitigation. For example, people feel that plantation will actually result in a climate change mitigation. Absolutely not. People feel that switching off lights here and there is actually will help in mitigating climate change. Absolutely not. The most stupid examples that are given, that while brushing your teeth, close the tap, while shaving, do this. That's so tiny and minuscule that it is not going to do anything else. What is required is drastic and immediate change. If your change is not drastic, if it is not immediate, you will never be able to mitigate the climate change. So the next question is, what could be the drastic and immediate change? What is possible? How do we do the drastic and immediate change in terms of energy? I believe that we need to switch 100% to solar energy by surrendering electricity connection. Give up your electricity connection. And especially academic institutions should do it. School, college, universities, institutions, all institutions that are running in daytime should become independent in terms of their energy consumption. That is drastic. And when should we do it? Immediately. We do not have time of tens of years and decades and decades. We do not have time. So therefore, it has to be done immediately. Even if you do it immediately, and even if you make a changes drastically, but if your change is again not following some fundamental rule of doing it, you will again cry 20 years down the line, you know, and we will create another problem. And that's what the modern humans are good for, you know. What does a modern human do? They solve one problem and not create other problem. That has been a great thing if we could do. Solving one problem and creating other is fine. Solving one problem and creating two problems, that is the problem of the modern human. So as a result, the whole world is becoming crazier. So what I say is, let us follow some fundamental rules of existence on this planet. If at all we want to live on this planet, there are something fundamental. And these are as fundamental as Newton law. Newton said, every action is a reaction. So you can't say that I don't like Newton and therefore I'm not going to follow every action as a reaction, right? It is beyond your control. You have to follow it. And similarly, I have given two fundamental laws of existence. We need to follow both of them. We can't afford to miss any one of them. This is based on Gandhian philosophy. Gandhiji said, look, the world has enough for everyone's need, not for anyone's greed. And Gandhiji said this 100 years ago, almost, when there was not so much of industry, when there was not so much of pollution, when there was not so much of trouble, still he said that. In fact, when you go into deeper, not only the Gandhiji, every religion talks about it. Every religion talks about it. So why Gandhi said this? And when I've been thinking about it, you realize that the whole planet is constant. It is fixed. The amount of size is, the land is fixed. We can't stretch it and make it bigger. The amount of water is fixed. Amount of air is fixed. The amount of soil is fixed. Minerals are fixed. Everything is fixed. But the arrogance of the modern human, or it is a scientific arrogance of the modern human, is such that we believe that with the science and technology, we should keep growing, keep producing more, keep consuming more. This is fundamental violation of law of human existence, and therefore we need to change it. So the law is that in an ecosystem of finite resources, there can only be finite consumption. Gandhiji was not a scientist, so he couldn't convert it into law. So what I did is I tried to put it in a more or less scientific manner, that in an ecosystem of finite resources, there has to be only finite consumption. We need to follow this if at all we want to survive on this planet. Limit your consumption is rule number one. Gandhiji said not the mass production, but production by masses is required. You know, why not mass production? Because every time we do mass production, it results in unequal distribution. Unequal distribution. And unequal distribution, whenever there'll be unequal distribution, it will result in inequity in the society. Inequity means lack of peace, more violence, and that is what exactly happening around us. In the last 30-40 years, love has not increased, brotherhood has not increased. On the contrary, the violence has increased. Therefore, what is a better model is a distributed production. That is what is required. You need to distribute the production. So therefore, the second fundamental law that I have written is that in an ecosystem of finite resources, there has to be distributed production. And this is also fundamental to the human existence. So in summary, what you have to say, limited consumption and localized production. This is the rule that you have to follow without failing. Limit your consumption, and whatever is the limited consumption, produce it locally. That is what we need to do. So when we do this, limited consumption, localized production, you can apply to the food, you can apply to the water, you can apply to the clothing, any other resource that we use. When we apply this to energy, it becomes energy Swaraj. When we apply to the energy, it becomes energy Swaraj. What is energy Swaraj? Energy Swaraj is about limiting your consumption. And whatever is limited consumption, produce it locally. That is energy Swaraj. So now, as I said, we need to switch to 100% on solar energy and follow these two fundamental laws. I have created a simple step-by-step approach on switching to solar energy. So if at all you want to do it, and we have no choice, we are forced to do that. If at all you want to do that, what you need to do, follow this three-step approach. Step one is avoid the use of energy as much as possible, even if it is solar energy. Don't use it. And I'm the brand ambassador of solar energy for government of Madhya Pradesh. I'm also professor of solar energy. I've been writing books and all. My job is to promote solar energy. But the first rule of using solar energy is don't use solar energy also. And why? This is very important to understand. Why? Because there is no manufacturing in the world which does not have side effect. Absolutely nothing. Everything has side effect. So whether it is production of modules, silicon, solar cells, modules, glass, wires, structures, electronics, batteries, all these arrangements are required before you can use solar energy. And all this requires energy. All processes require energy. Everything has side effect. Everything consumes chemicals. Therefore, the best thing is do not use solar energy also if it is avoidable. And I'm sure I've been watching this, I've been traveling, doing my yatra. I'm watching this people and what is happening. Let me tell you that 30, 40, 50% of energy is what? Misused, overused, or inefficiently used. Almost 50%. So what means that if you are becoming aware about this thing, almost half of energy requirements can be cut down up to 60%, even 65%. So the rule is avoid the use of energy. And I don't know, all the people, wherever you're sitting, I'm sure it is a broad daylight. I don't know whether your lights are on, why the windows have curtains and curtains are not open, So these are very basic example of how we can avoid. So when I started looking at my home in IIT Bombay, I thought that our, fridge can be avoided. By the way, today, it is the winter time, and I'm sure everybody has a fridge in your home. The question is, and I'm sure every fridge is on. The question is why it is on. The job of the fridge is not to save things, from the winter, save things in the summer. Why the fridge is on? That is wastage of energy. So when I started looking, I thought fridge can be avoided. The milk, the most perishable item, can be, boiled twice and it is protected. The vegetables should be eaten free, the fresh, and the food should also be eaten fresh. And therefore, we should avoid the use of refrigerator. Use of geyser, electric geyser should be avoided. AC should be avoided. One bath with the warm water, a nice bath, and 1 hour of air conditioning is equal to 1 unit of electricity consumption, which is equal to 1 kilogram of carbon dioxide emission. And this carbon dioxide is a 300 years lifetime. So 1 hour of comfort is a discomfort for 300 years. Isn't it crime that we are doing it by using and overusing energy that we are doing, and our children are going to pay for it? Second step is minimize the use of energy as much as possible using efficient appliances. The first is avoid it by 1/3. Next is minimize it by 1/3. So minimize the use of energy by 1/3 by using efficient appliances. You can use LEDs, you can use BLDC fans. The fridge and AC should not be used, but if at all you are going to use it, make sure that they are 5-star rated. So do that, to reduce your consumption further. The last step should be generate. So if you cannot avoid, minimize. If you cannot minimize, then only generate 1/3. And where should you generate? Generate it locally, wherever you are. Generate it locally. That is the step you're going to follow. So the rule is, if you're going to switch to solar energy 100%, follow AMG rule. AMG. A means avoid, M means minimize, G means generate. So avoid by 1/3, minimize by 1/3, and generate by 1/3. And if you're not going to follow AMG rule, you have to say OMG, oh my God, solar energy is expensive. Oh my God, rooftop space is not there. Oh my God, this is not there, that is not there. So when we won the competition, IEEE competition, and we got $100,000 prize in a grand prize in 2019, I have donated that money and started what is called Energy Swaraj Foundation. To establish Energy Swaraj in the world, everywhere in the world, not only in India, and the whole idea of this organization is to establish Energy Swaraj, encourage people to reduce their energy consumption, and then adopt to solar energy. And if you are not going to do this, so science and technology is not going to help us. So what I thought is that when I traveled also across the world in 2018-19, I saw that I went to 30 countries, in almost every corner of the planet, and rich country, poor country, developing countries. But I saw that the governments are not doing enough and probably cannot do enough to mitigate climate change because they are elected for short time, and also they do not have enough resources. So therefore, I thought of taking yatra, and climate change is a global problem. So 1-2 years of yatra is not going to be enough. So it is a 11 years long yatra where I've decided to not go home for 11 years and live in this bus. Right now, I'm sitting in this white window. You see the curtain, you can see. I'm right now sitting in the bus there. So I believe that the Energy Swaraj has to become a public movement. As I said earlier, the government actions will not be sufficient, and all of us have to take part in it. Everybody has to take part in it. So because everybody is user of energy, and as a result, everybody is a contributor to the climate change, and therefore everybody must solve it, not for the doing any social service or helping government, but do it for your own children. At least you want your children to live a healthy and happy life. You want your children to breathe air properly, to eat food properly, uh, and therefore you should do this. And I keep saying people that don't tell your children that I love you. The love that we have for children is really a fake love or nakli, because we have destroyed their own environment. They can't breathe properly, they can't drink water without filter, and they can't eat food without chemicals. So that is in a bad shape we affected, and therefore sustainability is already at the top. So let us do our role only because I want to help my children. And I believe academic institutions can really do a very important role in academic institutions, where the future of the future generations being created. So we should become the role model and demonstrate. And if the child learns that my organizations runs without any electricity connection, it is independent, it is energy efficient, I think that will be great impact and can really be part of the moment. I also created a certificate training course called Energy Literacy Training. I request IIT Indore and every partner organization of science forum to encourage and promote energy literacy. In fact, I proposed this to Chief Minister of Madhya Pradesh, Honorable Shivraj Singh Ji, and he has adopted it. And now energy literacy training, or Urja Saksharta Abhiyan, or USHA, is the part of the government policy now. It is being implemented by the government. So IIT should definitely do it. This is a website where you can do it. Also, Energy Swaraj Foundation does not take any money from the government. And we want to create a public movement, and we want your support to become part of it. I request all of you to become member of Energy Swaraj. We request a contribution of 3,650 rupees per year. So 3650 is a contribution. I request all of you to become member. You can go to this website, energyswaraj.org/member.php, and become part of it. Also, there is an Energy Swaraj Club. This is to promote the activities of reducing energy consumption, promoting awareness, etc. I request IIT Indore to start its own Energy Swaraj Club. We are going to send you more details on how to do it, what activities to perform. So request to do that, and that will be announced soon. So there are many ways each one of you as an individual, as an institution, as a student can take part in the Energy Swaraj movement. One of the things is that we are also going to organize a conference called Action for Restoring Environment. It is going to be a major conference. All of you are invited to be part there. And also apply for Energy Swaraj awards that are going to be announced soon. So there are many things you can become part of it. There is an app called Energy Swaraj Movement and Yatra app. You can download it and follow what is happening with the Yatra. I'm sitting in the bus right now. My bus is my home, where I sleep, where I eat, where we cook. There is a kitchen inside. Everything is inside. So I would say at the end, in summary, that climate change is a serious, serious threat to the existence of human beings. And we must do everything possible to mitigate the climate change before it becomes too late. All of us are contributed, and all of us must be part of it. Well, at the end, what I'll do is I would just like to play a small video or I'll share the video with you, and then we can take question answer. So once again, thank you very much for inviting me to be part of it. Thanks a lot. Over to you. Thank you, Dr. Sunil. Thank you, Dr. Ajay. And if there are any questions, I'll be very happy to respond.
Yes, sir. So thank you for such a sticking lecture, sir. It excited us a lot, and really very inside information. Like we usually think about energy, but in different dimensions. So you have given us a new, I think, thinking and ideas, and really we will be joined with your initiative like energy literacy and energy Swaraj Club. We will make our team from IT in those sides. And we already, there are a couple of faculty members who are working in energy related areas. So we try to join together. And,
Okay.
sir, this is mostly we are releasing this on YouTube because a lot of participants are there. So here we are having almost 30 people in the group in the WebEx. So if there's any question, we can look out. I think if participant want to share, they can raise the hand so that we can unmute. Otherwise, you can write your question in the chat box. Sunilji, would you like to discuss anything? I think we are not able to see any questions in the chat box now.
Yeah, thank you very much, Solanki sir. It was, very illuminating talk, I would say. You know, since you have been doing this, I totally agree with your point of view that, government cannot do it because they are myopic in the sense that, they have been elected for 5 years. And so it has to be a, people-led movement. So how much change do you see? Because you have been traveling a lot and, in your experience, how much of change, how perceptive or receptive people are of your ideas? Do you see people changing a bit? What's your
Well, I mean, I must. I keep thanking Corona more than anybody else. I think because of the Corona, people are at least willing to listen to the problem, and in the critical way that I present, that it is really crime that all of us are committing today. Not only crime, I keep telling that it is, in Indian mythology, it is nothing less than a pap that we do, that we emit carbon dioxide today, and somebody, bears it for 300 years. So people are ready to listen to this and understand that this is a problem. Of course, the manner in which we are growing, it has been 30, 40 years, and just one idea is not going to change immediately and suddenly. So the direction in which we are going, we must slow down first, then we should stop, and then probably you should start taking the U-turn. So I'm very kind of positive and hopeful. And that is where my energy comes from, that I see that there is a slowing down, people understand, and I'm sure people will adopt this idea of energy Swaraj sooner than later, and take pride in saying, I do not have electricity connection. Take pride in saying that I'm not part of the pollution, I'm part of the solution. They take pride and put a kind of a flag in front of their house saying that house does not have carbon emission. So when the things change in that perspective and we start taking pride in doing things that we are supposed to do, I think it will result in a public movement. And that time will soon. It's already, a lot of things are happening where people are sensitive enough to do that, and some people are already doing it.
Okay, thank you, sir. Ajay ji, anything else you wish to discuss?
Actually, sir has to leave as sir has updated us.
Yeah, just 1-2 minutes, 1 minute, and then my time is up.
So Dr. Sanjay Singh is with us. Dr. Sanjay, would you like to say something?
So lighting is problem here. So thank you, Professor Solanki. It's a very nice talk. And so one thing I would like to ask, what is the role of industry in this whole movement? Because the solar thing,
as I said, first of all, two things that I said are fundamental to our existence. Now,
Yes.
when this fundamental means it is applicable to individuals, it is applicable to organizations as well as to industry. So even industry has to follow those limited consumption and localized production. And the approach that I've said is AMG. So I believe that irrespective of who you are or whether you're small or big, I think it is so fundamental in nature that everybody has to follow them.
Yeah. Related to this, one more thing that, in fact, you have touched those components when you say like avoid using solar. So because for solar consuming solar energy, there are so many things are involved, like battery, and then battery includes lithium and nickel, and the so many things are there. Like, so how that is contributing? It's overall, it is also contributing.
Well, as
to
I
the-
said, there is no manufacturing in this world which does not have any impact on the environment. Absolutely nothing. It can have less, but not zero. And that's why the solar is also having less impact. The per unit electricity consumption, the carbon footprint is 40 grams as compared to 1000 grams for coal. So it is less, but not zero. And therefore, the best thing you can do in this world is avoid use of energy. Do it passively, don't do it actively. And there are beautiful ways in which it can be done. People have been doing it before us. It's only as I said, the stupidity of the modern humans that we do it in this manner. But there are better alternatives to do it.
Thank you.
All right.
Sir, thank you very much for giving your time and sharing this important input with us. And hopefully we will connect in some other event, and we will join your Swaraj Foundation movement. Sir, thank you very much.
I hope in IIT Indore, the students and faculty member, everybody becomes energy literate soon. And we establish Energy Swaraj Club so that we can keep doing these activities, not only limited to IIT Indore, but IIT Indore can lead in the entire Madhya Pradesh, and become the role model. Thank you very much.
If we commit from our side, we'll try our best. Thank you, sir. Thank you very much.
Thank you. Thank you.
Thank you. So, Sunilji, still for next lecture, we have almost 10 to 15 minutes, right?
Yeah.
So, let's have a break for 10 minutes and we can join at 11:30.
Sure.
Yeah, people can be there. I would request the participant to be here. Please don't leave, but you can take a physical break from here. Okay. Sunil ji, good morning. Hello. Sunil ji.
Yes, yes, Ajay.
So
Next up,
Professor
Professor.
joining soon. I just spoke to him.
Okay.
So
Prashant Paridar, right? Or Berdar?
हाँ हाँ सर हेलो So he's joining. There's some connectivity issue, so
Okay.
trying. I will join soon.
So Dr. Prasad is joining. I think there is some network issue their side. So he's saying it is connecting, but it's still taking some time. So we just can beat.
Good afternoon, everyone. So next speaker, we have Dr. Sanjay Singh. Let me just briefly introduce Dr. Sanjay Singh for those who are not aware or from the other institute. So Professor Sanjay Singh is actually working at IIT Indore. He is a associate professor in the Department of Chemistry. So Dr. Sanjay Singh received his PhD degree from APS University Rewa, and he was working as a CSIR SRF with Professor DS Pandey at BHU also. After that, Professor Singh was a JSPS postdoctoral fellow as well as AIST postdoctoral scientist at AIST Osaka, Japan. Subsequent to that, he was Alexander von Humboldt postdoc fellow with Professor P.W. Roski at KIT, Germany. Since 2012, he is working at IIT Indore. Since 2017, he is associate professor. So, as far as the research, the interest of Professor Singh is concerned, he is a expert in the area of hydrogen production and storage, and his current research is focusing on the designing and development of new catalysts for hydrogen production, storage, carbon capture, and utilization. Also, he is interested into the biomass transformation to fuel. So now I would invite Professor Sanjay to give us, a brief. I mean, his talk will be of 45 minutes, and he will be talking about the hydrogen fuel for clean energy. Sir, please.
Yeah. Am I audible? Am I audible?
Yes, sir, you are audible. No, sir. Now you are not audible. You were audible earlier.
I'm audible now?
Now we are audible. Yes, I can hear you.
Yeah. Okay. So let me share first. I hope slides are visible.
Yes, sir. Yes, sir. Visible.
Okay. Thank you, Dr. Sunil, for the introduction. And I would like to firstly thank the organizers for inviting me for this Renewable Energy Conclave and giving me this opportunity to discuss some of our work on hydrogen fuels first. So since morning, like Professor Solanki has very much explained like how responsibly we should behave and utilize energy in a more proper way. And he mentioned few of the things about like drastic and immediate action is required, like the way we are utilizing energy. And that is very much relevant for all sources of energy we are using, be it solar or wind or the other way, or like hydrogen, which I'm going to talk about. And I would further extend his views, like he discussed about the ignorance of human society in exhausting the available resources, and it's not just the way we are exhausting it, how it deteriorating the environment. So that is very much important. And in this scenario, like I'm going to discuss about hydrogen, and I'll start with this slide. Where we can see different modes of transport, okay? And here we can see particularly the black balloons. So these black balloons indicates like how much gram of the CO2 is generated per person per kilometer travel. So we have been listening like we should be using public transport. Like if you see public transports, so these three public transport, and it has very small balloons, which indicates like okay, so per person CO2 emission is quite less, and because with almost like similar fuel consumption, the more people can travel the similar distances. So that is important. But And if you see different type of the personal vehicles we are using every day, it has a very big balloons and which indicates like how much CO2 emission is being generated. So in particular, important components are these two closures, where both are the electric vehicles, and but one of the electric vehicle has a very big balloon, and while the other one is not. So it indicates like how effectively and how properly we are utilizing the energy. And one is working with the green power, another one is the traditional power we are utilizing from by burning coal in thermal power stations. So one way we are considering electric vehicles as pollution-free vehicles, but while charging the electric vehicles, how this electricity is being produced. That is an important component. And what Professor Solanki has mentioned, the important component which is missing in all type of energy resources is how it is affecting the environment. And so that is very much important. And if we have to have electric vehicles in place, we should be having more power station which generate green power. Okay? So the lesser CO2 emission in principle. This pie chart indicates like how much CO2 emission is generated, and particularly if you see almost 62% of the CO2 is being generated only by burning fossil fuels, and we are utilizing fossil fuels not only in for the transport but in all sectors like burning every day, and that's why the CO2 emission is there. And the bottom picture indicates the CO2 emission in a million metric tons by different countries. And if you can see, India is on the third largest in CO2 emission after China and US. So we have a much greater responsibility, responsible nation, and the quite well in different sectors of renewable energy, and that's why we are discussing all these things very actively. So the transport sector itself contributing, it's a bigger contributor to CO2 because we are using vehicles every day. And burning oil, gas, and coal, it has much contributed to the CO2 emission, and it is escalating every day, year by year. So what is the alternatives? So alternatives could be biofuels and the electric vehicles, as I mentioned, and the windmill and wind power or the solar power. And it has shown quite aggressive potential in the renewable energy sector, and we must be knowing about the International Solar Alliance, where India is leading the globe in particularly the solar power station. And India has set up so much of solar power and is progressed quite well in this direction, though with less contribution in the windmill, and that is because these stations or the windmill power stations are very much area specific, and several other factors are also involved in this. But the good thing is that India is working quite good in this generating renewable energies, utilizing it as energy efficient systems. And we have been seeing these electric vehicles, I just discussed before also, everywhere, and being it the vehicles or the public vehicles or the personal vehicles or the public transport, everywhere electric vehicles are there. And electric vehicles is being running on lithium-ion batteries, and with a very simple system, a lithium-ion battery, which is a power supply, and a motor. And that's why the demand for it, this indicates how much the lithium-ion batteries demand is increasing in India. It is growing and escalating very frequently year by year. But the problem with the lithium-ion batteries, if you see this pie chart, which indicates the availability of lithium worldwide. Okay, so you will not be able to see India or even Asia in this pie chart, because the larger amount is in the South America and West So that's why the India will be like dependent on other countries, like the way we are dependent on fossil fuels for lithium ion resources right now. So India has lack of lithium reserves, and that's why it will increase our dependency on other countries for lithium resources. So it will greatly influence our efforts towards electric vehicle based systems. And not only this, the component, and it has adverse environmental effect. You see, these two pictures indicate lithium and lithium mines, and this is the nickel mines, and these are open mines. So we can understand like how much energy and efforts are being involved in this, and when we have open mine, how much it is affecting the environment. So it's not just the deforestation; it produces a lot of carbon emission is there. So, so much things are involved, and we just not see one component, and we have to see like what are the different processes involved and how it is affecting the environment also. So in this scenario, hydrogen is considered as an important fuel of the future, and the important not only is the fuel of the future, it's clean energy, and because it has very well balanced the energy content, if you see, and it is CO2 free transport because it generates only water as a byproduct, and that's why it will also able to cater the global energy demand, reduces oil dependency, particularly in the Indian perspective, and it has no greenhouse gas emission, so it will be very much friendly to the environment. If you see the energy content, it is almost like more than twice to the fossil fuels. So that is not an issue. The water is the only byproduct of the hydrogen. By utilizing hydrogen as a fuel, either in the internal combustion engine or as the fuel cell, and that's why it is able to reduce significantly the greenhouse gases if we completely switch to that hydrogen fuel based systems. So it will be benefited to the air pollution and sustainable transport. Problem with hydrogen is it has very low volumetric energy density, and so that's why the storage of hydrogen is a big challenging task. It's not only the storage, its transportation and dispensing is again become a problem. So just an example, like if we have to run a hydrogen fuel vehicle for 100 liters, you need to have 11,000 liters of tank if you store hydrogen at atmospheric pressure. So we can understand like how much volume is it itself. So, of course, these are the engineering challenges, and that can be tackled easily. So, effectively, if you see the hydrogen-based society, it has three components. So, hydrogen production, storage, and utilization. And hydrogen production has like the hydrogen can be produced by biological routes, electrolysis of water, chemical production, steam reforming, coal gasification, thermal, chemical, and there are several ways. And it's not that hydrogen is right now it is in the centerpiece, and that's why we do not have any process to produce hydrogen. But actually, we have to see like how effectively hydrogen can be produced without harming the environment. So one of the things is the hydrogen production, the storage component, how hydrogen can be stored conventionally, because when we produce hydrogen, hydrogen is lighter gas, so it can easily can be it's difficult to store in that sense also, and so that's why how we can utilize, store it, and use it when it is required. And utilization component, how hydrogen can be utilized for the generation of electricity. So it fuel cell, and as I mentioned, the internal combustion engine work is also coming up. So people are working on that. So there are different ways of generating, and it's not only the transport, like all the generators which are running on diesels and CNG, that can be also converted hydrogen-based systems. So this picture is very much in line with how these different sources of energy like the solar, wind, or hydro, which are very much environment friendly. They can work in synergy with the hydrogen, and it's a very good example of all these renewable energy. They are complementing to each other. It's not they are competing to each other. So with all these limitations, let me take you to some of the advantages and limitations with the hydrogen fuel vehicle. Hydrogen fuel vehicles are very much in the market, and the in different countries, people are using it. It is available for buying also. And as India has also declared that they are working extensively. I'll give some examples in the part of my talk. So see, in terms of mileage, it is very much similar to that of the petrol-based vehicle, and it's running is also easy, like with single time charging 300 to 450 kilometers. Hydrogen fuel buses can run, and the most important, which is very much lacking in the electric vehicles, like the charging time. So hydrogen fueling time is equivalent to that of petrol. Like the way we are utilizing CNG based vehicles, the similar way hydrogen can be fueled in very effectively. As I mentioned, like limitations, since it is developing stage, so the cost is a factor, and infrastructure is still in the developing stage. So it will improve particularly as time goes on. So that's why the world is preparing well for this hydrogen and taking it very well. This picture indicates the projected the global footprint of hydrogen fueling stations. You can see the projection is quite increasing because it is escalating, is expected to escalate in all sectors, like in Asia Pacific and European region and American region. They have prepared in one of the script, and then it is projected to increase well by in the next 10 years or so time. So as I mentioned, like different countries already have hydrogen fuel vehicles. That's why it's not just hydrogen fuel vehicles will come, and one should also have the infrastructure involved in this. So these are some of the snapshots of the hydrogen fueling station, and you cannot not be able to differentiate it with the regular petrol-based filling stations. It is very much similar to that. This one is from Japan and Germany and US and in Singapore also. Like, so you can see, like, it's very much similar to that. So and world is working quite well in this direction. And that's why hydrogen is being used in all sectors, in the personal vehicles or the trains, airplanes or metros or heavy-duty trucks. So in all sectors, it is well proven that the hydrogen fuel vehicles can get all type of vehicles transport system. Indian initiative, if we talk about, very recently this is shown in exhibition, which is very much indigenously developed fuel cell based bus, hydrogen fuel bus, and Tata has also developed hydrogen fueled bus, and India is also planning to apply this hydrogen fueled hybrid train systems. Like this one is the Kalka Simba. So they are trying to hydrogen fuel. So, and this hydrogen as CNG is one of the things, like where CNG vehicles we are very much known. CNG is where 18% of hydrogen is blended with CNG, and it has very much prominent effect in reducing the carbon emission, and as well as the efficiency, fuel efficiency increases significantly. This is very much indigenous technique. This picture is simple hydrogen fuel cell based vehicle. You can see hydrogen tanks, which is carrying hydrogen, and you have a very small battery that is for the backup, and the hydrogen is supplied to the fuel tank, where you can, this picture indicates the fuel hydrogen is coming to the anode, and then it generates electricity, and water is released as a byproduct. So this is a very simple system, and we just have a power control system and a fuel cell system. Cell-based electric vehicles. So I mentioned about the challenges with the hydrogen. The storage is a big challenge, and right now the commercially available systems which store hydrogen at 700 bars, so that it can give significant amount of hydrogen content for driving a vehicle. So that needs to be reduced because 700 bar is quite high pressure. And also a mindset needs to be changed, like hydrogen is equivalently safer than petrol. So those kind of mindset needs to be changed. So all these things are a very good indication, because it is projected that hydrogen demand is going to increase is not only for the transport system, it is going to in all sectors. You can see power, the transport, or everything. So the problem with hydrogen is not only that how hydrogen can be stored or transported. It is also important to understand, like hydrogen availability is very so it's a very good thing. Like hydrogen is everywhere but nowhere. Hydrogen is the most abundant chemical substance in the universe. But if you see in terms of hydrogen gas, which is two molecules, its abundance is less than 1 ppm. So hydrogen can be generated, and that is important. And it can be generated through different ways, like ammonia cracking or the thermal cracking of methane, methanol, or water gas shift reaction. You can see, and these are well-established processes. Electrolysis of water is very efficient system in one way, because it does not have any carbon emission, and that's why it is important. But unfortunately, in India or the globally, if you see a lot of amount of is being produced from hydrocarbon. So that's why, because one way we are saying that hydrogen is a clean fuel, because when it burn or when it is utilized in the fuel cell, it generates only water molecule. But the another way we are generating for generating hydrogen gas, we are generating lot of amount of CO2 emissions. So that needs to be, if you see the water gas shift reaction, one molecule of CO2 is generated with one molecule of hydrogen, or CO is generated with two molecules of hydrogen. So a lot of CO2 is also generated. So that needs to be avoided to establish that hydrogen is there. So the way hydrogen is being produced, hydrogen has been categorized into different color coding, like the brown hydrogen, which is produced from coal, and where CO2 is released in the atmosphere. Gray hydrogen, where hydrogen is being produced from methane, but CO2 is again released in the atmosphere, which is should be avoided. And the blue hydrogen, where CO2 is produced from methane, but CO2 is captured and stored. The carbon capture is very much based along with the hydrogen production system. And of course, the green hydrogen, where hydrogen is being produced from the sources where there is no carbon. So ultimately, this high carbon, the brown hydrogen and the gray hydrogen, needs to be avoided, while the blue hydrogen, which is a low carbon systems, and while the green hydrogen, which is zero carbon, needs to be promoted. These days, this pink hydrogen and other different color codings are also available. It depends on like pink hydrogen is when we utilize atomic energy for the generation of hydrogen. So these are important, but in terms of if we relate it with the environment, so these color codings are very much relevant. In low carbon hydrogen production or zero carbon hydrogen production needs to be promoted. Okay, very quickly to this chart, and where we can see different type of particularly solid state hydrogen storage materials, and target area is where we can get a very good volumetric and the dispensing parameters for the release of hydrogen gas. Now, I'll take you through this liquid organic hydrogen carriers, and according to the Department of Energy, this department, and the blue enclosure, which indicates the efficient DP target can be achieved if we have materials in this window, and see methanol, ethylene glycol. It's very much efficient, have volumetric capacity and gravimetric capacity, so that it can be able to generate a amount of hydrogen gas. So what are liquid organic hydrogen carriers? So these are organic compounds which can absorb and release hydrogen chemical reaction, usually with the reaction of a catalyst. And why I'm talking about liquid organic hydrogen carriers, because I mentioned two problems with hydrogen is this hydrogen availability and the storage of hydrogen. So hydrogen, since it is a gas and it's a very light gas, storage is a big challenge. So if we have a liquid which can store hydrogen, and whenever it is required, it can release hydrogen, that kind of material, which is, if it is liquid, it is transported. We are transporting the petroleum petrols. So just an example, like it's a simple alcohol we have, where we have CH bond and hydridic hydrogen and the protic hydrogen, and it is with the release of one hydrogen molecule, and this is the release of hydrogen. And when we need to store hydrogen, so it can be again hydrogenated and it can be converted. So one molecule of hydrogen can be stored easily with this. So this is one of the example, and based on the different carriers, hydrogen can be stored and the relevant amount. So the advantages of utilizing liquid organic hydrogen carrier is that being liquid, it can be stored as a transportation and dispensing using correct infrastructure is possible. And as mentioned, like Professor Solanki is also mentioned, generating locally. So on-demand hydrogen production is a very well-known term in hydrogen-based society, where hydrogen can be generated on board or on demand. Okay, so quickly discuss some of these examples where results. I have some 10-15 minutes more. So starting with hydrogen, which is a rocket fuel. Consider this is toxic for a human, but satellites love it. And because it is extremely toxic, caustic, and carcinogenic, spontaneously explode and neurotoxin. So it has all the bad things it has, but it is very attractive because it does not have any carbon atom. So in terms of that, you can see it's a zero carbon hydrogen source. So it can be utilized in an efficient manner if we can add one water molecule to this, the hydrogen monohydrate. It can be it is a liquid which can store hydrogen, and you can see 8 to 8% of hydrogen is there. And the important thing is that it has only nitrogen as a byproduct, which does not need recycling, but recycling can be done. And as I mentioned, since it is liquid, it can be easily recharged using and available infrastructure. So this molecule, if you can see, these two blue are the nitrogen, where we have nitrogen single bond, and the 4 hydrogen atoms to each of the nitrogen atoms. The decomposition component, if you see like how hydrogen can be generated from hydrogen, favorable part is the incomplete decomposition, and where there is no hydrogen release. So the suitable catalyst needs to be utilized to facilitate the complete decomposition of hydrogen, 2 molecules of hydrogen and 1 molecule of hydrogen. See the decomposition pathway. If you see both the processes, whether it's incomplete or complete, both initially started with this activation of NH bond. However, in the incomplete decomposition, the NN bond cleavage also occurs, and the NH2 molecules is generated, which further react with H add atoms to form ammonia. While in this case, we have only H atoms over the surface, which further recombines to form hydrogen molecule and nitrogen as the. So these all things can be done with the intervention of a catalyst, and effectively when this hydrogen molecule interact with the catalyst surface, NH bond cleaved, and then H atoms they combine to form hydrogen molecule, dyne, and then further the nitrogen released with the further the same process. So hydrogen and nitrogen can be released over the catalyst surface. So with this, different type of catalyst has been explored for this, and which release give us 3 sets of catalysts. If you see this one, which are inactive, the copper, nickel, Fe, platinum, palladium, which are completely inactive, because this y-axis you can see the amount of hydrogen released per molecule of the hydrogen, while ruthenium, iridium, and cobalt was found to be only 7% selective for hydrogen. The only rhodium outperformed, where it 43% of hydrogen selectivity is observed. Further analysis, you can see this is the mass of the released gas, and you can see hydrogen and nitrogen are very prominent peaks. At the same time, in the 59 NMR, you can see ammonia formation, which indicates that both the processes are working simultaneously, and that's why it leads to this process in this particular formula. So further working on the catalyst designing and then alloying catalyst with the some non-noble metals with the rhodium and nickel, and we can see nickel, which is inactive, when it combines with rhodium in a specific manner, so 100% selectivity for hydrogen can be released, can be achieved. At the same time, we have seen nickel and the platinum both are inactive, but in a specific composition, we could achieve 100% selectivity. So these are the important information about the catalyst designing. You can see the inactive nickel and 43% rhodium, and combine the specific ratio give 100% selectivity for hydrogen. And hydrogen and nitrogen peaks can be seen very easily, and there is no ammonia formation observed. So this is all happens because nickel has the capacity to activate NH bond, but it does not have the efficiency or the amount of energy to release H atoms as hydrogen molecule. In that manner, these platinum, palladium, or the metal helps to spill over those H atoms over their surface, and then they recombine to release as hydrogen gas. Similarly, homogeneous complexes, you can see here with the relevant tuning of the ligand site, we can achieve high activity for hydrogen decomposition to hydrogen release. And here again, the process works in the similar fashion, where the coordination of hydrogen with the metal center and the simultaneous activation of NH bond is the hydrogen gas or nitrogen gas, where hydrogen gas is released with the formation of this dihydride species, while the nitrogen is released with the formation of NN bond. So there is no NN bond cleavage. So this is also we have observed a similar manner, where initially hydrogen coordinates, we have identified this molecule, and then with the release of one molecule of hydrogen molecule gas, this diene molecule, and then further with the intervention of this negative species, nitrogen is released, and metal hydride species is formed. This hydridic hydrogen and the protic hydrogen, they recombine to release as hydrogen gas to regenerate the catalyst species. I mentioned like nitrogen is not required to be recycled, but it can be recycled using different existing processes to back to the ammonia or hydrogen. Quickly moving to formic acid. which is a liquid and it has a 4.48% of hydrogen, and it can release hydrogen and CO2 molecule. Different sets of catalysts has been explored so far for formic acid decomposition. And if we properly tune the ligand site, we can achieve high activity. And a proper set of ligands needs to be utilized. This whole process of the catalyst activation and involvement of catalyst, we could monitor what are the different species are formed, but the most important species are the formation of aqueous species, or the coordinatively unsaturated catalytic species, or the formation of this metal format species. So if you see this formic acid decomposition process, the important species is the metal format species, and which further undergo decarboxylation to form metal hydride, and then this metal hydride reacts with the proton from the solution to release as a hydrogen gas. So these are important components. In all these processes, the coordination of the substrate with the metal center or the catalyst surface, and then further activation of relevant anions. So these catalysts are very active, and because they can be recycled for several cycles, and you can see hydrogen and CO2 is generated. So methane reforming is one of the important component. Methane can be with the release of formic acid and hydrogen molecule, there is no CO2 emission, but further CO2 formic acid activation to CO2 and hydrogen is a very favorable process. So that's why it completely decomposes into 3 molecules of hydrogen and 1 molecule of CO2 from methane. So methane reforming occurs at a very high temperature, and so we need to develop processes where hydrogen can be released at much lesser temperature, like 100 below 150, and the catalyst must be inexpensive, and complete activation of methane is required. Methanol is required. So for that, we have explored different type of catalysts, and what we have observed, lithium is quite active. And when we further fine-tune different parameters, we could achieve very high activity, high conversion of methanol hydrogen gas. Okay. So here you can see different type of ligands we have explored. What we have found, like when we have this 2-hydroxypyridine, high activity is achieved, and we can also see the comparison of this the red trace and with the black trace with the ligand. Certainly, there is a significant enhancement in the conversion part. Okay. And the catalyst characterization also indicates nitrogen is indeed present in the catalyst surface. So it indicates like this hydroxypyridine is participating in some way in the activation of methanol. Now the most important component is with methanol. What we have observed, you should not be able to see any CO2 emission. So which is very much important. Like as I mentioned about the blue hydrogen and the green hydrogen. So we are able to restrict the hydrogen release purely. Like there is no CO2 emission. Even if you can see here, this process, this is 13C NMR, where you can see a very small peak. This is a zoomed view for the carbonate, so which indicates like this reaction is very much restricted up to the formation of format, and there is only 2 molecules of hydrogen is released. It's very much pure hydrogen, so with no contamination. And that's why we are able to further recycle the catalyst, and we could generate a lot of amount of hydrogen gas, which is very much pure in all the cycles. So we could achieve like 1 kg of hydrogen can be released with 13 liters of methanol, and with at a very less temperature if we compare with the processes. this process can further be extended for the generation of hydrogen, which is pure. Again, I'd like to mention it's pure hydrogen. Ethanol, where we can see like 1 kg of hydrogen can be generated from 3 liters of ethanol and at much lesser temperature at 110 degrees. The other important thing is glycerol, which is a byproduct of biodiesel, which constitute almost like 10% of diesel, and it is in fact it's a waste material. And so we develop a process where we can also generate hydrogen, which is again pure hydrogen, free from CO, carbon, and with this process we can also generate lactic acid, which is a very valuable chemical which has its commercial value. And 1 kg of hydrogen can be generated from 52 liters of glycerol at much lesser temperature. So it's a benefit of converting a waste material into hydrogen. At the same time, we can get a material which is very much industrially important. Lactic acid, it is utilized for the formation of biodegradable plastic materials. Formaldehyde, which is a very important component. See, I am discussing about all these C1 based systems here again, which is, you can see this is formic acid and this is formaldehyde. And formaldehyde itself, it has 8.28% of hydrogen. And even if we take the aqueous formaldehyde, it has 5.8% of hydrogen. So it has high content of hydrogen. With the proper utilization of different catalytic process or the designing of the catalyst, high hydrogen content can be achieved and the complete conversion of hydrogen can be achieved with this process. So we could see the formation of methane diol, which further coordinate, and then activation of this methane diol, formation of metal hydride species, and the catalyst can activate formaldehyde to formic acid, and then formic acid further can be used to hydrogen and CO2. Okay, so we have seen like the bulk production of hydrogen. This formaldehyde can achieve a less amount of CO2 is generated in the initial stage. So the last part of my talk is about the environmental pollution, where we can utilize PET waste for the production of hydrogen gas. We have developed a process where PET flex we are utilizing in everyday life, and these PET waste can be further be utilized for the generation of hydrogen gas, where 60-degree we could achieve in a one-pot process. Hydrogen, which is hydrogen, again, it is a pure hydrogen. There is no CO2 emission, CO2 release, and large amount of hydrogen can be generated, like 1 kg of hydrogen from 33 kg of PET can generate. And at the same time, tephthalic acid and the format is formed, which has its own commercial value. You can see like tephthalic acid itself is for almost like 90 rupees per kg, and format is almost like 200 rupees per kg easily. So it has commercial value and it reduces the hydrogen cost. So with this, I would my presentation, and I would like to emphasize hydrogen production and hydrogen utilization is important, but at the same time, we have to see like how hydrogen is being produced. Of course, utilization of hydrogen does not release any carbon emission, but for the production of hydrogen, we have to also see like it should not generate any carbon emission. So that's why the green hydrogen and the blue hydrogen, where we have a properly set up carbon capture techniques. So these are the promising areas where hydrogen can be generated in efficient system. And we have to work and more responsible manner to utilize energy and generate hydrogen system. I would like to thank my group and the financial support from different agencies, institution facilities. Thank you.
Thank you, sir, for this very, very good talk. I learned a lot. So I would invite the participant if they have any question. I ask them to drop something in chat window also. But I think most of the participants are through either YouTube or they are sitting in the room itself. Okay, there are some positive comment from student Kriti Rai from JEC. Any questions from the participant audience who are attending this talk online? No. Sir, may I ask a couple of questions?
Sure, sure.
Yeah. So one of the things, like, a common perception, I would say, as far as the hydrogen is considered, is, that it is explosive. Like, even the static electricity, we have heard the accident in some labs, just you touch with hand and, it sort of explode. So you showed some pictures where people are filling hydrogen gas just like, petrol. Is it true? Like, I mean,
Yes, yes.
what are you-
See, hydrogen can be easily handled in the same manner because the way we are using dispensing the CNG gases, no?
Right.
In this similar manner we can utilize it. So
Okay.
that's not an issue.
So-
Only we have to avoid trigger.
Okay, the
Because-
spark.
Yes. So the same way, the petroleum also, if
Correct.
there is any spark, then that will also lead to the formation of fire. Or other.
Okay, right. So, I mean, another thing is, like, talk about the storage. So I read somewhere that, the hydrogen is so small that it can, even through the stainless steel, across the grain boundary, it will go and it will start diffusing and, embrittles it. Basically, the mechanical strength of your container itself, with time degrades very severely.
Yes.
So are the people are using something extra to sort of
Yes,
make?
see, that's why that is the biggest challenge. Otherwise, the job will be very easy because we already have established CNG-based cylinders
Correct.
and utilize it. But the hydrogen, which is a very smaller molecule, it can penetrate through the steel bud. So we cannot use that one. So all these containers needs to have a particular different type of polymeric liners are required.
Okay.
So those kind of engineering is required so that it should not penetrate. Because once it's penetrate through the cylinder, it will break down, and then hydrogen leak and the accident will happen.
So another, like, a couple of questions I have, that, like, you talk about this catalyst. So how good are these, like, in terms of the economic scale? Because I saw it is ruthenium. You
Yes.
said that 6 gram for 1 kg of this one. So economically, how much? Like, what is the status?
See, if you talk in terms of industries, so industries does not talk about all things depends on how efficient and what is the lifetime of the catalyst. If suppose if we use nickel or some other catalyst which degrades very quickly or
Right.
leaks out from the solution, so it will not help you because so for industry when they run a system they need a system catalyst which has long lifetime, and the how much cycle or the life cycle will reduce the cost of the catalyst.
Okay.
So that is one of the component. Of course, people are working on reducing the cost. But even if you see, like most of these catalysts, they are using platinum. The industries, they're using platinum. For the cracking of the petroleum products, they're using platinum. So
Yeah.
less expensive, but the important thing is the life cycle, productivity.
So it is cost effective over the life cycle in this sense.
Yes, sir. So larger will the life cycle, the cost can be compensated.
And then just a final question from my end is, like, this PET bottle, which is very common. So when you are taking hydrogen out of it, like, what is the nature of the byproduct? Is it also a waste? Like,
the byproduct, the taphthalate. See,
PET bottles.
yes, sir. So see, maybe I'll take you to that slide. So if you see like the taphthalate, as this is taphthalate.
Right.
Okay. So this is the one of the monomer of this polymeric system. Okay. You have taphthalate, and you have this linker. This linker
Mhm.
is ethylene glycol.
Mhm.
So what we used to do, like we use the catalyst and then we just put this flakes directly in our reaction container. Okay, and then it leads to the formation of hydrogen gas,
Mhm.
and these two products are there:
Okay. So,
tephthalic acid and the formant, and these are solid product. There is no PET flex.
okay.
These two are further can be extracted like as crystals, solid
Okay.
materials.
Okay. So it's not like it must be useful, right? Somewhere.
No, yes, yes. That's why I mentioned, no, like it has commercial value. Like see here, I mentioned this tephtlate.
Okay. Oh, this would be 93.
Yeah, it's 93 rupees per kg, and the potassium format is 20 rupees per kg. So these are very valuable chemicals, and this tephthalic acid, in fact, it can be utilized for the formation of this PET bottles again. Like,
Well,
these are
recycling.
ingredients, yeah. So this can be further reutilized.
Mhm.
This one can be further reutilized. This can be utilized as a hydrogen source again.
Okay. And just what over the cycle, this like this hydrogen production from PET waste, how much energy we are putting in, and how much hydrogen energy in terms of, let's say, efficiency. Any?
See, we have calculated some of the things like 9 liters of hydrogen per gram of catalyst,
Okay.
whatever available resources we have, right? Or 1 kg of hydrogen can be generated from 33 kg of this is the projection.
Okay.
So several, if you talk about the cost and other things, like when we work in the laboratory scale and when we compare
Yeah.
it to industrial scale, so several
Scaling
capital.
completely changes the scenario.
Yes, yes, yes.
Okay, sir. Thank you very much. It was, very, very illuminating at least for me. I'm sure everyone who attended this talk must have learned a few things about the hydrogen energy. So on the behalf of MPVS, I once again thank you for your talk. And to the rest of the participants, we will probably meet at 2. Then we will have another talk on energy management at efficient use. Thank you, Sanjay sir.
Thank you. Thank you very much.
So good afternoon, everyone. Dr. Ajay, are you present?
Hello, sir.
Yes, Ajay is there?
No, sir, he's
Okay,
not
fine.
here.
No problem. I think Mr. Vivek Sharma is already here, Devendra Vishwakarma. So probably we will start with him. Okay, so a very good afternoon, everyone. So the next talk in this MPVS, the Conclave for the Renewable Energy, we have Sri Devendra Vishwakarma, who is working as the VP as well as the CTO of PT&D Digital Solutions. So he is responsible for the technological vision, solution, architect, roadmap and management of digital solution in the field of energy and smart cities domain. Mr. Sri Vishwakarma has studied MSc in electronics, and he has also done his MTech from the in instrumentation from Devi Ahila Viswavidhalaya in year 1999. So, Sri Vishwakarma, if you are here, you may start presenting your talk.
Sir, I can't see him in that.
No, he's there in the attendees. I think you have to give him the basically you have to add, maybe you can add him into the panelist so that he can present. I think he is muted.
Got it. Yes, sir. Now you can control from your end.
Right. So yeah, Sri Devendra Vishwakarma, can you hear us? I cannot unmute him. Let me see.
Are you able to hear me?
Yes, we are able to hear you. Thank you.
Okay.
Yeah,
Thank you.
you are loud and clear. So you can present your slides now if you have.
Sure, thanks.
Thank you. So just to reiterate, Vishwakarma ji, so we have some participants who are online. We are also having this same presentation live streaming on YouTube, and there are some students who are attending this in lecture complex. So there also this thing is being short of broadcasted. Okay, please go ahead.
Awesome. Thank you. Yeah, Dr. Sunil, I'm getting some problem. I will have to rejoin again because I need to because I just got the sharing permission. So I'll have to reconnect. Somehow it's not
Fine.
starting. Give me just few seconds.
No issue. Please take your time. So to the rest of the participant, this talk would be on basically energy management and efficient use, and this talk will be of 30 minutes. If you have any question, you can drop the same into the chat window and we will try to take up with the speaker. Right, so he's online.
Hi everyone. Are you able to hear me now?
Yes, we can hear you.
Sure. Yeah, sorry for this last second technical glitch. Let me share my screen and we can get started.
Right, we can see your screen.
Awesome, thank you. Hi everyone, thanks for joining this session, and thanks to IIT Indore for giving me the privilege to come and talk on the topic of energy management and efficient usage. So as Dr. Sunil already introduced me, I am representing L&T Power Transmission and Distribution Digital Solutions Group, which is part of L&T Construction. And I'll talk a little bit about myself and then get started with the main topic, not to bore all of you, but few words about me. I graduated in the year 1999 from the VLA University, did my master's of technology in instrumentation and control. Since 2003, I have been in the United States, and currently I am working as Chief Technology Officer at Larsen and Toubro for their power transmission and distribution group, based out of Dallas in Texas. And I have 21 plus years of experience in the area of renewable energy, distributed energy, resource management, microgrids, energy automation system softwares. And I work with various utilities across the globe, as well as GE, Alstom, and the vendors like that, where I have held various positions in the management with them as well. I've implemented many projects all over the world in the T&D automation domain, transmission distribution automation domain. And I have also acted as a thought leader in this area, working with various standards like P2030.5 and 1547 and many other standards I contributed towards there. Coming to the topic of discussion today, I know it's a renewable energy conclave, and this is very relevant topic in the sense that energy management and the efficient usage of the energy that is, I mean, it's the talk of the day from various aspects. If we look at, there are three different verticals when we look at from the energy management perspective. One of them is energy management for the electric grid. We all know from the industry perspective is the energy management system for transmission, distribution management system for distribution grid, and generation management system for generation grid, generation plants, right? Which is primarily used for monitoring, control, and management of flow of electricity at T&D networks while maintaining the reliability and resiliency of grid. That's the objective over there. Then there is energy management for industrial and commercial campuses. It is for C&I customer segment, what we call in the industry. That's focused on the optimized use of energy with focus for sustainable operation and reduce cost of energy operations. This is the end use energy management. So that's that. Then energy management for smart buildings and office complexes, where the object is more the sustainable operations while providing the least cost of energy to tenants of these campuses. In today's topic, because we have limited time, these are very vast topics, and there have been conferences just dedicated on this topic alone. So I will just touch base on one of the verticals, which is the energy management for industrial and commercial campuses. This is something which I have focused for last 10 years, working with very large corporations like Koch Industries in USA, Intel, and many other like Global Foundries and GE and other companies as well, focusing on the energy management for industrial and commercial campuses, mostly focused on sustainability, carbon reduction, and the renewable energy implementation for those campuses. So what's the importance of energy management and efficient usage from the customer segment, what I'm talking about, which is the industrial and commercial segment, which is, for example, industrial parks, shopping malls, and those kind of things. this is a very, vibrant topic in other parts of the world, which is United States and Europe. India is still catching up, and we have seen very recently there have been some new initiatives which have been launched by the ministries, Ministry of Power, and the other government agencies in India as well, which is very encouraging. And the ESG goals, I would say the environmental sustainability goals for the corporations in India is taking shape as well, and companies are, the industry is really focusing, and they are paying attention to this particular area, and hence this becomes a very important topic for the industry. And I would say that there is a lot that needs to be done from the academia and industry collaboration perspective as well. There have been some new initiatives, some funding opportunities which are there internationally available, as well as available with the Department of Science and Technology in India. Now, why it is required and why it is important? See, if you really look at the mix of energy usage for any city or for any state or a country, the larger set of energy usage is dedicated to the industrial and commercial segment, because they are the large loads. They are the ones who get the economy going, not undermining the significance of the residential loads or residential customers, but a single customer, which is an industrial or commercial for an electric utility, could be equivalent to maybe 5,000 or 10,000 residential customers in any given city. So from that perspective, these are four quadrants around which the importance of energy management and efficient usage, which we in turn call energy efficiency, can be seen. So the first one is controlling and reducing energy consumption. Energy management is the means to control and reduce an organization's energy consumption. And controlling and reducing an organization's energy consumption is important because it enables them to reduce costs. This is really becoming fast becoming and increasingly important as the energy costs are rising. Means what you see across the globe these days, during the pandemic, after the pandemic, and even before that, the gas prices, they have a direct hit on the energy prices at the wholesale level, and in turn for the industrial and commercial segment, means this is something which is ever growing. Energy cost from one contract to another, when it comes up for renewable renewal, there is always an increased cost for them. So how do they use the energy management and efficient uses of the energy to reduce the cost? That is important. Then the third one is the reduction of carbon emissions. Means sustainability is the new keyword for the corporations. It helps them promote their image as a sustainable operation, as well as the ESG reporting is becoming more and more important by the regulators. If you really look at large corporations, ESG finds a significant portion into their annual filings with the ACCs or the equivalent like SEBI in India, the Security Exchange Commissions for the publicly traded companies. Then from the business continuity perspective, this is important to reduce the risks as well. The more energy an organization consumes, the greater the risk that energy prices will increase in the future, and those increased energy prices and the supply shortage could seriously affect the profitability as well as impact the business continuity. So from that perspective, with the energy management, they can reduce this risk by reducing their demand for energy and by controlling it so as to make it more predictable. So that's what that is. So these are the four parameters of importance from this topic perspective. Now, I'll walk you through a case study and how the industry looks at when we, from industry perspective, we go and approach. For example, L&T goes and approaches an industrial campus or a large manufacturing. We ourselves are large manufacturers. When we go and work with large manufacturers for Industry 4.0 or for energy efficiency, energy conservation measures, ECMs, those kind of things, this is what we typically go through and entire life cycle for an energy management and energy efficiency program. It ranges anywhere from I would say 12 months to 18 months, and sometimes it goes over 18 months as well, depending on what kind of customer we are talking about, what kind of industry we are talking about, you know. So let's take an example of a semiconductor manufacturing facility, which for whom it's a continuous load, and from that continuous load perspective, the resiliency and reliability is of the paramount importance. But then, because it's a constant load and constant demand, their energy bills are quite high. So from that perspective, how do we go and implement an energy efficiency program or implement an energy management program plan for an efficient usage of the energy? So typically these projects, from our experience, I'm telling you, any engagement when we go and work with the customers, it starts with an energy baselining, which typically runs for 2 to 3 months. Then we go and identify the savings and do the calculations for those. For example, IIR calculation, the NPV calculation, those kind of things. That is important because ultimately we are talking about the industrial commercial segment, which is for-profit organization, and hence for them, their primary objective is to optimize usage of energy while reducing their energy cost of energy operations. And typically that takes around 1 to 2 months. Then, of course, because based on how to implement the energy efficiency measures, or how to implement the optimized energy, there has to be a business case that typically takes 1 to 2 months of preparation. And then there is a 3 to 5 months of activity for design, construction, and verification. For example, typically it starts with reducing the energy by implementing more energy efficient equipment, for example, HVAC systems, or means changing the heating cooling system, or changing the lighting and those kind of things. And then looking into if we have to manage the demand, if the load is going to grow, or if we know that the demand charges or the energy prices are going to go higher, can there be an on-site generation that can be implemented? Most of the cases these days, I've seen in last 2 to 3 years, or even longer than that, the customers are really opening up for renewable energy, on-site renewable energy generation, either by using fuel cells or using the energy storage system clubbed with the solar, rooftop solar, or the ground-mounted solar. The organizations are also looking for creating that renewable energy ecosystem by providing innovative incentives to their employees to adopt to the electric vehicles and those kind of things. So it's a cool, it's a total cycle which has just started, and we are seeing more and more such programs taking shape in the industry. Means we have seen it last over 5 to 7 years in western part of the world. India have started interacting with various customers here as well, which are large multinationals like Amazon and others, we started to implement these kind of programs. And from the renewable energy ecosystem perspective, source of microgrids or on-site generation via mix of renewable solar and the fuel cell technologies that is taking place. Now, once this design construction verification happens for whatever measures have to be implemented, then the implementation, operation, and monitoring goes on for 6 to 9 months, where measurement and verification data is collected so that we can go and look at how well it is aligned with the business case. Are we on track to realize the savings by which the objectives can be met? This is the starting of it, and then of course there is a continuous operation, continuous verification, measurement, verification, and the improvements into the energy ecosystem of campus that goes on. So that is that. Then these are the typical energy management and efficiency program outcomes. So I told you about different stages of a project, but then what does that entail? You know, what do customers look for? What does the industry look for when they are talking about implementing an energy efficiency and management program? So from the energy baselining perspective, the energy accounting of the current energy usage is done, where the data is collected for past bills, meter data analysis. That's the same time when new sensors and some metering equipments are implemented. As I mentioned, Industry 4.0 is also driving these new initiatives because of the advent of IoTs and the digitalization of the manufacturing plants. I mean, today morning there was a report that manufacturers, the auto manufacturers, are less worried about, I would say, the impact of the COVID or the pandemic, because what they did, they utilized the downtime to digitalize their entire process and put more and more sensors into the plants. And now those are the ones which can be now utilized to better analyze or do the baselining of these things. You know, then identification of variables out of businesses control, which is sort of things which are the regulatory framework, right? Means your local utility, your energy regulatory commissions, and any other external factors which may impact an overall energy program. Whether an energy rate normalization of energy data, and then finally the KPI establishment for the project savings from energy efficiency and energy management measures. Then the second stage is where we do the energy master planning, where the baseline is used to calculate the savings from ECMs, which is energy conservation measures. There are study simulation of the ECM options, and that's where I would say, because we are talking in the context of industry as well as in the context of academia, as it is initiated by IIT Indore. I mean, this is one area of industry where academia can contribute quite significantly, which is the study simulations and coming up with new tools. If you really go across the industry, and I'm talking specifically in the context of India and Indian paradigm, most of these tools, they come from outside of India, which are more geared towards Western way of using the energy. There is really no solution which I have come across which can be used specifically for baselining and simulation over an energy scenario for next 15 to 20 years, keeping Indian scenario in mind. And that's where just like means the universities in USA or in Europe, they came up with new tools. Here is an opportunity for the industry, for the academia and industry to collaborate and come up with new simulation technologies, new tools, new applications there. Then the next one is where we do the calibration of the ECMs for the businesses energy baseline, prepare the options to implement the ECMs, and the facility-wise based energy efficiency solution is calculated. That's where the energy master planning happens. The energy master plan typically happens for both greenfield as well as brownfield projects. Greenfield, it's a no-brainer because there is nothing which exists. Brownfield, that's where it's always challenging, because if a manufacturing plant or an industrial plant, they have a 20, 30, 40 years old machine, how do you retrofit that? How do you put new sensors and those kind of things? That becomes a challenge. And that's where a lot of work that needs to be done. Then business case is prepared and an EMP roadmap is developed where optimal scenarios selection to implement the ECMs is found. For example, do we need to do the equipment retrofit? Do we need to put on-site energy solution, for example, in microgrid or on-site generation? Or goes without saying, energy efficient lighting, which is always the first step towards implementing an efficient energy management program. Then we go into the business case with the CapEx and OpEx projections and ROI, and the stakeholder management for any project which goes on, that's done. Once everything is there, it has been approved, we get into design construction verification, where the permitting, energy contracting, negotiations, those kinds of things take place. The actual construction, whether it's an upgrade, retrofit, repair, or replacement, that is done. Installation of associated equipment is done. And once design construction is done, goes without saying that the actual solution is implemented, or the actual energy management and energy efficiency programs are implemented with the objective to safeguard the return on investment via real-time monitoring of equipment energy system. That's where the energy management comes into play. The equipment performance measurement and tracking. This is yet another topic which is of interest from the industry perspective, to work with academia to identify new technologies for performance measurement, tracking, usage of IoT, usage of AI/ML, artificial machine learning technologies, as well as development of new, I would say, new algorithms and new methodologies. That's what we can work together. EMP KPI tracking, which is energy efficiency, microgrid, on-site, and so forth. The equipment longevity is the ultimate goal of this particular phase of a project. Then there is a measurement and verification. Ultimately, the system, the solution, and the folks who have implemented it or who are operating, they have to make sure that there is a business buy-in for the KPIs, and then there is a documentation of those goals that the ECMs are designed to achieve progress, monitor, and tracking. Here, I will give you one very small example because this is all related to the sustainability of the energy operation, or sustainability of any business operation. Typically, a large industrial setup. Let's take an example. Maybe Coke Industries in USA, or Intel, or those kind of things. Their sustainability group, which is typically part of facilities management or the energy side of the facilities management, they spend at least a month every quarter to document the sustainability reports, which can then be filed for the regulatory compliance purposes. Energy efficiency and energy management systems which get implemented, they reduce that time from 1 month to few hours of production of those reports. So right there is a huge efficiency gain for this industry as well from there. So with that, this is my last slide, where a typical implementation for manufacturing customer or an industrial customer who have multiple sites, and it really doesn't matter whether it's in one location or another location. It could be in different geographies, different countries, and all those kind of things. Um, where each site has its own energy management systems for the buildings, which are there. There are IoT gateways, sensor actuators are there. All this data is then collected from the sites using a telecom they call IP network. This could be a public or a private network. And then this data is used for various purposes in the name of energy efficiency and sustainability solutions. So here, as I mentioned, carbon accounting and sustainability reports is one major goal of implementing this kind of solution. Energy auditing and accounting, safety and security management. Cybersecurity is becoming a big issue these days. On one hand, IoT gives an opportunity to collect the data and digitize the networks or the systems, but then it is creating a challenge from the cybersecurity perspective as well. And we all are aware of what's going on these days in the world with more and more connectivity. We are having less and less secure systems, and that's where there is a continuous effort from the industry to keep systems, networks, and solutions safe and secure. Then there is asset equipment network monitoring and maintenance, the campus energy efficiency performance monitoring and management, and then finally, which is the finance part of it, the energy billing and contracts management. So that's a typical architecture, and that's where, Dr. Sunil, I will end my presentation. And if anybody has any question which I can answer, means I'm more than willing to do so.
Thank you very much, Devendra ji. It was a fascinating talk. So either the panelist or the participant, if you have any question, so probably we'll take maybe a couple of questions, a very quick question. If you have any, please do ask. You can unmute yourself and you may ask question. Okay, so it seems there is no other question. So Devendra ji, I have just a brief, a small question. So, yeah, so my question is regarding, you showed that, you have basically you want to improve the system, and, there is a 12 months of short of cycle that you identify the problems as a solution and other thing. So if you go to the technological aspect of that, let's say we talk about the energy storage. We see that every 6 months, every year, there is a new breakthrough, something new is coming, or there is a, enhancement in the, let's say, energy density by 10% or 15% or 20%. Similarly, you have solar cells, so newer and newer solar cell with better efficiency, they keep on coming. So how do you, like in the energy management, how do you, predict or basically take into the account that within 1 year, within 2 years, the whatever solution you are suggesting, that might be obsolete? Like, we have cell phone, and every 2 years, short of new chips comes, new hardware comes, and so on and so forth. So do you have anything for that also? Like, how do you account for that? I hope my question is clear.
Sure. So, yeah. No. So, Dr. Sunil, this is very relevant, very good question. And this is typically always, we are in a paradigm where there are always technological advancements and technological breakthroughs. But if you look at what happens in the practical world, while there are new breakthroughs, while there are new technologies which are being developed, there are two things which we look at. One, the maturity of the solution itself. So let's say there is a new chemistry which is found for the energy density improvement and all those kind of things. it will take at least a cycle of 7 to 8 years for that technology to be matured. And then it has to go through the compliance process, the certification process, and all those kind of things. So typically when we are designing a solution, let's say an energy storage for microgrid kind of setup, in that case, we take whatever has already been proven. It has to be certified. It has to be compliant with the grid codes. And that's what we do. And typically, the life cycle of the solution is 10 to 15 years. So we do consider that the battery pack, for example, in energy storage system, will have to be replaced in 10 years. So by then, if there is a new chemistry which is there, now we can just go and swap out. That's how the systems are designed. The energy storage systems are designed, or for that matter, solar is little more tricky because their typical life cycle is 25 years, right? 20 plus years. But then the efficiency goes down and there are retrofit programs. So after 10 years, whoever signs the PPA, or I mean, if it is a PPA model or a build, own, or operate model or those kind of things, that time in the calculation, the business case calculation, there is a replacement cost or retrofit cost, which is already considered. That if there is a technological advancement or the breakthrough which comes, we consider those as part of our calculations for financial analysis perspective. So yes, we do take care. So there are two short answer is, we do take care that over a period of time, 5 to 7 years, there will be something new which will be proven in the industry and which will be compliant with the grid code and certified by the regulators. So we consider that as a retrofit or replacement, as well as over a full life cycle of, let's say, 20 years plus, or typical time is 20 years. In that, one full replacement of energy storage system and 30% replacement of the solar panels is what considered in this kind of implementations.
Right. Thank you very much. I mean, so in a sense, like you're looking for maybe TRL level 8 or 9, right? Somewhere there, only those solutions you're suggesting. Right.
That is right.
Right. Okay. Devendraji, thank you very much for this talk. And once again, probably if in future we have some conference, we will again try to invite you, maybe a bit more elaborate talk. But nevertheless, on the behalf of MPVS, I would like to once again thank you for this talk. And now we have next speaker, I think Professor Prashant Baredar. Sir, can you hear me? Lokanath, maybe you need to give access to Professor Prashant.
Yes, good afternoon, sir.
Okay, you have already given. Fine.
Yeah.
Okay, let me just introduce very briefly because Professor Prashant could not give his talk because of some technical issue. We could not connect him to the internet. So Professor Prashant Baredar is currently the chairman, and he's a full professor in the Department of Energy Center at MNIT Bhopal. He has over 20 years of experience in the field of thermal energy, thermal engineering and integrated energy systems. He holds 2 patents in the field of wind turbine blades, and he has over 100 publications in peer-reviewed international journals and then, of course, in several conferences. Apart from this, he has also contributed as the editor as well as the reviewer for several reputed journals. So without further delay, I would invite Professor Prashant Baredar to present his talk. Sir.
Thank you very much, sir, for such a nice introduction. A very good afternoon, you all. At the outset, just a minute. At the outset, I would like to extend my sincere thanks to the organizing committee of this Renewable Energy Conclave and MPCST Bhopal and IIT Indore for inviting me and allowing me to share my views with you. So today I am going to present the topic wind tower design under various requirements. So let me share my presentation. Actually, I am not used to this WebEx platform.
Okay, sir, I think you are sharing your entire screen. So probably even now, if you can open your PPT, probably it will come. Or you can just share one part of the screen. Right, we're able to see your desktop. If you click on this, yeah, sir, we are able to see it. So you can go to maybe full screen, it will come.
Okay. So is it visible to all of you?
Yes, sir, it is visible.
So the topic of my presentation is wind turbine tower design under various requirements. I am Dr. Prashant Bharadar, Professor and Head Energy Department, Maulana Azad National Institute of Technology, Bhopal. So before looking the procedure of tower designing, what is wind actually? So the sun rays falling on the earth hits the air particle unevenly, and as a result of that, temperature difference occurs, and the kinetic energy possessed by the air particle moves from one place to another. That causes wind to blow. Generally, the moderate to high wind speed, which is typically around 5 meter per second to 25 meter per second, are considered favorable for most wind turbines. As far as origin of wind is concerned, different types of winds are there, like local wind, geostrophic wind, global wind. So the origin of wind may be traced basically to uneven heating of the Earth's surface due to sun. And this may lead to circulation of widespread winds on a global basis, producing planetary winds, or may have a limited influence in a small area to cause a local wind. There are two different reasons for global wind to blow. The primary force, that is due to differential heating of the Earth at equatorial and polar region. And second is the spinning of Earth upon its own axis, which produces actually a Coriolis force, and which is responsible for deviation of air currents. As far as local wind is concerned, the land masses and the sea surfaces. So the land masses gets heated more quickly and gets cooled down more quickly in the evening time. In the daytime, gets heated more quickly, and in the evening time, gets cooled down more quickly as compared to the sea surfaces. And that is why the temperature difference occurs between the land masses and the sea surfaces. And this is the reason to blow the wind. That is actually a local wind. There are numerous factors which are responsible for distribution of wind on the surface of the earth. They are both global as well as local factors which influence the availability of wind at the particular site. And on the planetary level, the great mountain masses influence the circulation of air currents. Then the surface roughness or the friction, that is also responsible for the wind to blow, which is due to the resistance that different elements of the earth's surface like hills, tall buildings, trees, and similar obstruction that impairs streamline air flow. Wind velocity in horizontal direction gets markedly reduced. Wind speed also increases while passing through narrow mountain gaps where it gets channeled. So let's have a look at the top 10 wind turbine manufacturers. This is the data of 2019 actually. So it is Vestas. Vestas is German-based company. They have collaboration with RRB, Indian-based company. Their share in the market is around 12.7. They have installed so far 5,217 megawatt wind turbine capacity wind turbine. Then followed by the next wind turbine manufacturer, that is Sinovel. Their share in the market is 9.0%. And they have installed so far 3,700 megawatt wind turbine capacity. Then Goldwind, their share is 8.7%. Then Gamesa, their share is 8.0%. Then Enercon, share is 7.8%. General Electric Energy, their share is 7.7%. In Suzlon and Repower, their share is 7.6%. Guardian United Power, their share is 7.4%. Then Siemens, share is 6.3%. And the Mingyang, their share is 3.6%. They have installed around 1,500 megawatt wind turbine capacity. As far as record holding turbines are there, the largest wind farm means where there are number of wind turbines at one place, that is called wind farm. So as far as largest wind farm is there, Gansu wind farm in China is the largest wind farm in the world with the largest capacity of 20,000 megawatt by 2020. And as far as largest capacity is concerned, the Enercon E126 has a rated capacity of 7.58 megawatt. It has an overall height of 198 meter and a diameter of 126 meter. And it is the world's largest capacity wind turbine since its introduction in 2007. Means from 2007 to till date, it is still a largest wind capacity turbine, Enercon E126. As far as largest swept area is concerned, swept area means area swept by the blades of the wind turbine. So the largest swept area wind turbine is a prototype installed at Gamesa and Dowling, Zaragoza in Spain in 2009. That is the largest swept area wind turbine in the world. G10X, whose nameplate capacity is 4.5 megawatt and has a diameter of 128 meter. As far as tallest wind turbine is concerned, the Furlander wind turbine Lasso, its axis is around 160 meter above the ground, and that axis is taken from the center of the hub to the ground, and that axis is 160 meter, and its rotor tips can reach a height of 205 meters. Rotor tip means where one of the blade is exactly at the vertical position, so that rotor tips can reach a height of around 205 meters. It is the only wind turbine in the world taller than 200 meter. Means rest of the wind turbines are less than 200 meter height. As far as most productive wind farm is concerned, there are 4 wind turbines in the Ronland wind farm in Denmark. They are the most productive wind farm in the world, and each is generating around 63.2 gigawatt hour wind power. As far as highest situated wind turbine is concerned, the world's highest situated wind turbine is made by Divind, which is located at Andes, Argentina. It is around 4,100 meters above the sea level. Then there is a broad classification of wind turbine, that is horizontal axis and vertical axis. Horizontal axis wind turbine means whose axis of rotation is horizontal, whereas the vertical axis means the axis of rotation whose axis of rotation is vertical. So as far as vertical axis wind turbine is concerned, Lee Nordice wind farm, which is at Captured, Quebec. It is the world's largest vertical axis wind turbine, whose axis length is 110 meter and nameplate capacity is 3.8 megawatt. And as of November 2020, the Roscoe wind farm is the largest onshore wind farm. These are other criteria of classifying the wind turbine, that is onshore and offshore. So as far as onshore wind farm is concerned, this Roscoe wind farm is the largest onshore wind farm whose nameplate capacity is around 71.5 megawatt. Then in the India, the largest wind farm is at Jaisalmer wind farm, which is the biggest wind farm in India. It is developed by Suzlon Energy, and followed by another wind farm that is a total capacity of 1500 megawatt, that is in the Mupandal, Tamil Nadu, which is second largest wind farm in India. As of now, the country currently has a fourth highest wind installed capacity in the world, with the total installed capacity of around 39.25 gigawatt. Some of the future wind power plants in India that can be seen here. So 102.4 megawatt Sipla wind farm, which will be located in Jaisalmer district, Rajasthan. The commissioning is already started. Then the 50.4 megawatt Narmada wind farm, that is at Nalgonda, Andhra Pradesh. Then 200 megawatt wind farm in Tamil Nadu, which is installed by Techno Electric Engineering Company Limited, TECL. Then Kaparo, which is building 500 megawatt wind farm in Rajasthan, Gujarat, and Maharashtra, and they have placed around 1.2 billion ordered $1.2 billion order with the Suzlon. Then 56 megawatt Tupadalli wind farm by Asunia. Then 50 megawatt wind farm in the Amreli district of Gujarat by Orient Green Power Company. One more by Orient Green Power Company, that is 84 megawatt wind farm in Maharashtra, and 33 megawatt wind farm at Vellapaneri wind farm by Beta Wind Farm Company, which is a 100% subsidiary of Orient Green Power Company. So these are the advantages of wind energy, which is a renewable source of energy. It is ample, adequate quantity of wind energy is available everywhere. Only need is to harness that energy. The wind energy is a renewable one. It can be reused again and again. It is widely distributed everywhere. It is cheap and also reducing toxic gas emission. Then wind energy may soon be the cheapest way to produce energy on the large scale. The cost of producing wind energy has come down by at least 80% since 80s. So if you compare from since 1980s to till date, the cost of producing wind energy has drastically came down. So a lot of scope is there in the wind power technology, and the greatest advantage of this wind power technology is to diminish the greenhouse effect. No greenhouse chances of greenhouse effects are there, no pollution. Then the fact is that the wind will exist till the time the sun exists, because it's another form of solar energy, and the main cause of wind to blow is solar energy. Sun rays falling on the earth, which hits the air particle unevenly. Okay, so that is why it is roughly another 4 billion years sun will exist, until then the wind energy will also exist. If all the wind power available to humankind is harnessed, there can be 10 times of energy we use that is readily available. So this is all about wind energy. So I will directly come to the tower designing part. So tower is one of the very important component of the wind turbine, which provide the support to the entire assembly. Okay, it is like a cantilever type member. Okay, so this tower supports the nacelle. Nacelle means where the hub, then gearbox, then coupling, generator, everything is there inside that nacelle. So that part is called nacelle and the rotor. So its height is approximately 2 to 3 times the blade length. So whatever the blade length is there, so 2 to 3 times of that, generally the tower length is kept. Okay, so around practically the tower height is around roughly 60 meter, and it is designed to withstand the wind load during the gust. And at the bottom level of the tower, there is a step-up transformer for the connection to the electrical grid. And inside the tower, there can be a ladder for climbing purposes, for carrying out the maintenance activities, and for maintenance activities and other activities for reaching at the top of the tower, etc. So a ladder is provided there, and the cables, electric cables, that can also be run through that inside the tower. Okay. Then why taller turbines are required? So actually, as the height of the tower increases, wind speed also increases. So up to Ekman layer, uh, that is around 2000 kilometers. So wind speed increases with the height. So we get stronger wind at the greater height, because as the height increases, the nearby obstacles like tall buildings, tall trees, such obstacles are not there. So due to that, stronger winds is available there at the greater height. So taller turbine increase the energy production by accessing stronger wind, steadier wind, and increasing the wind turbine blade length. So each meter gained in height increase the energy yield by around 0.5 to 1%. Tall turbine towers, around 80 meter, 60 to 80 meter tall turbine towers are there. They may be steel tubular towers uh, generally, and the goal is to design the towers of 100 meter, 120 meter, or more than that. And the issues which are related to this upscaling the steel tubular tower design, they are prominent importance. Then optimum tower height. So the height which is required for particular turbine. So for keeping optimum tower height, because generally if you go on increasing the height, okay, definitely stronger wind or steady wind you will get, but the cost associated with that will also increase. And second thing, failure, turbine failure, tower failure, chances of tower failure, they are also there. Okay, so there are two growth functions. So increase in height increases the cost and energy also. So theoretically, the optimum tower height lies at the point where the two growth functions. So as far as cost breakup is concerned, around 74% cost is of other components, whereas 26% cost is associated with the tower of the wind turbine. So new technology in the wind turbine towers are concrete turbine tower, hybrid turbine tower, USCP, that is ultra high concrete. We'll see it one by one. So as far as steel towers are concerned, there are different advantages of steel tower. They are made from rolled steel plate. Hence the tower is robust, and because of its closed structure, the internal parts are well protected. They are durable and ductile. They can handle large deformation, high tensile strength, and smaller foundation. Disadvantages are also there for steel tower. That is more height definitely cost more. Then installation can be painful. Need a very big crane and big lift, big crane, big big crane and big lifts are required for installation purpose, for maintenance purpose, for assembling purpose, and which can lead around, which can at least 100 tons. Then corrosion resistance over the steel tower to protect it from the corrosion and rusting. Then then less welding jobs is needed. Then design is more flexible. Anytime we can assemble and deassemble the member. Okay. So this is the biggest advantage of this lattice type. The structure can be built at the location of the wind turbine directly. But there are some disadvantages, that is bolted connections may cause issues and it's a time consuming process. So the better solution means in between the steel and the concrete tower. So the steel hybrid towers, they are gaining more importance. So the steel advantage of steel hybrid towers are combined properties of the steel and hybrid, then easy to transport, lighter than concrete, smaller foundation, etc. Whereas the disadvantages are heavier than steel, larger foundation, and utilizes two materials, that is steel and concrete. Okay, so more complicated construction process and many more. Then nowadays the USCP, that is ultra high concrete performance tower, ultra high performance concrete tower, they are gaining more importance due to the advantages of precast section is here. The different precast sections are there and they are assembled at the location of the wind turbine directly. So transporting this precast section is very easy as compared to the complete tower. Then minimal field labor and crane rental, easy to transport. Then USCP is stronger in tension as compared to the steel tubular tower and concrete tower. The members are smaller and lighter, and expected lifespan is around 40 plus years. Whereas it faces some disadvantage also, that is weaker in tension than steel and still undergoing testing. Unproven technology means research is still going on. Then some special case towers, that is spiral stairs. That stairs are provided for climbing, for reaching at the top of the tower easily. Okay, and due to that, anytime access can be possible. Okay, then the step tower, that is for easy assembling and for easy climbing, for maintenance and assembling purposes. Then for smaller size wind turbine, generally guide towers are used. Okay, so if the thin tower is used, so for stability purpose, the wire ropes are used for providing extra support. Okay, their advantages are weight saving, cost saving, as well as simple construction and easy maintenance. As far as foundation is concerned, different types of foundations are there: monopile, tripod, jacket. So we'll not go in much detail due to shortage of time. Okay, so we'll directly come to the design of turbine towers. So this is about history of the development of the tower. Typically, two types of loads are considered, that is static load and dynamic load. Okay, static is actually a tower head weight and the tower's own weight, whereas the dynamic, that is due to rotor resonating with the tower's natural bending frequency and vortex-induced vibration of concern during the construction and while rotating the blades, and that fatigue is directly proportional to the wind speed and the turbulence. The main cause of failure in the tower is a buckling. So most common mode of failure of the turbine tower is buckling, and that is caused due to the extreme loading or fatigue load. So there are mainly two types of failure in the tower, that is buckling and bending. So buckling is due to the weight which is acting on the tower, that is the nacelle weight and the complete assembly weight, whereas the bending, that is due to excessive wind pressure. So before designing the wind tower, we have to calculate some design parameter, that is allowable stress design, So the allowable bending stress, that is FB, for non-compact section is around 60% of the yield stress. 60% of the yield stress, in which yield stress is denoted by Fy of the steel tubular structure is typically around 345 megapascal, and allowable shear stress is 40% of the yield stress, that is denoted by mu. The allowable compression stress Fa is represented by this equation, equation 1, that is allowable compression stress Fa is equal to 1 into K into L upon R, that is slenderness ratio. K into L upon R is called slenderness ratio, where K is the effective length factor. Here in this case, it is taken 2 for cantilever type structure, because this wind turbine tower is a cantilever type beam. So effective length factor is taken 2, and L and R are the length of the tower and the radius of the section. Then material coefficient is calculated by this expression given in the equation 2, that is under root 2 pi square E upon Fy, okay, where E is the steel modulus. Now, if the slenderness ratio, that is K into L upon R, is greater than material coefficient, then in that case, this allowable compression stress F shall be recalculated by using this equation 3, that is 12 pi square E upon 23 into slenderness ratio, square of the slenderness ratio. Okay. Then the ratio of applied axial compression stress, small fa, to the allowable compression stress, capital Fa, of the steel tower is generally 0.15, less than 0.15. So the combined stress for the applied bending stress Fb acting on the steel tower shall be satisfied with the entire this equation given in the equation 4, that is small fa upon fa plus small fb upon fb, that should be less than or equal to 1. So in this way you can check whether the stresses are within limit or not. So the applied shear stress from the torsion and the shear force on the tower shall also be less than the allowable shear stress Fu. So here it is given that small Fa, that is applied compression stress, capital Fa is allowable stress, allowable compression stress, that the small Fa is applied bending stress, capital F is allowable bending stress, Mu is the site coefficient as a function of site, and 1 second period maximum considered earthquake. Then the second parameter which you need to calculate, see, that is local buckling stress. So the strength of the tubular steel tower in the axial compression is lesser of the yield strength, and the elastic critical buckling stress, that is sigma critical, that can be calculated equal to 0.605 E into T upon R, where R is the cylinder radius and T is the wall thickness and T is the steel modulus. And then as per steel tower design, the radiation coefficient alpha 0 for axial load is given by this expression given in the equation 6. So if this R upon T, that is the cylinder radius and thickness, wall thickness, this ratio is less than 212, then you will use first expression, whereas if it is greater than 212, you will use the second expression. Now the bending load, the reduction coefficient for bending load is calculated by the equation given in the 7, that is alpha b is equal to 0.1887 plus 0.8113, the compression load, reduction coefficient of compression load. So in this way, buckling stress can be computed using this yield stress Fy. Okay, so the reduction coefficient for compression load and building load. Okay, by putting this value for this alpha b into sigma critical, if it is greater than half of Fy yield stress, okay, then in that case first expression will be applicable, and if it is less than half of the yield stress, then the second expression will be applicable. So in this way, buckling stress can be calculated. Now the third parameter you need to see, that is earthquake load. So even though the earthquake load seems to be not much significant effect on the design of steel tower, because of the fact that wind turbine towers are placed in a low seismic area. So generally before finalizing the site for the wind turbine, generally the low seismic area is chosen, but still you need to see the earthquake load. Okay, so in this graph you can see the overturning moment, earthquake overturning moment for different height, that is 10, 20, 30, 40, and so on. Okay, so you can check the different overturning moment for different height. Then earthquake load can be see like this. So for that purpose, a tower period T can be estimated. Okay. So by using the empirical formula, that is T is equal to CT into H by H to the power 3 upon 4. Okay, where CT is equal to 0.02. So that is considered in case of wind turbine case, and the T is equal to 1.5 times TA. So this T is actually a tower period. So the tower period T can be estimated by using this formula, and this TA is approximate fundamental period of the tower structure. Then the dynamic behavior of the steel tower can be checked in this way. So natural frequency of tower is greater than the blade passing frequency is said to be steeper. So natural frequency of tower should be greater than the blade passing frequency. Whereas tower's natural frequency between the rotational frequency and the blade passing frequency is regarded as soft. So this estimated natural frequency of the tower can be calculated using this expression given in the equation 11, where estimated natural frequency equal to 1.75 into under root EIG upon H cube into weight of the tower, weight of the tower, weight of the head mass, and the weight of the tower. Head mass means the weight of the nacelle. Then there are various methods of increasing natural frequency because it should be more than the blade passing frequency. Okay, so mainly the two methods are there: by reducing the mass of the system or by increasing the stiffness of the system. So the natural frequency of the system can be changed either by varying the mass or stiffness. So however, reducing mass is never desirable. So it is governed by the structural requirement. So that is why stiffness of the system you need to enhance. So that is what's shown here. That is a steep tower is considered when the natural frequency is greater than the blade passing frequency, and if that natural frequency is between the blade passing and the rotational frequency, then it is considered as a soft tower. And if it is frequency is less than the rotational frequency, then it is considered as a very soft tower. Then the dead load. Dead load is considered as a weight of all the materials construction incorporated into the structure, that is tower and the wind turbine. Then the wind load. Wind load is actually it depends on the wind speed, shape, and height of the structure and the topography of the region. Now, before designing this tower, you need to see the directionality factor. This factor generally is depends upon the type of structure. Which type of structure is there? Whether tall building is there, or tower is there, or arch roof is there, or chimney is there. Okay, so accordingly, this directionality factor is considered. Okay, so the wind load factor changed when the directionality factor was extracted. So generally, for wind turbine, the directionality factor is considered as a 0.85. Then you have to see the importance factor. So importance factor is depends upon the type of building better whether it is of category 1, category 2, or category 3 or 4. So low hazard to the human life is considered as the category 1. Then moderate risk is there, then category 2, and high risk is there, that is category 3 and 4. So here in this case, um, low hazard because generally the wind turbines are installed at the remote area. So there, that's why the importance factor is considered as a around 0.77 or at the most 1, that is moderate risk. Then surface roughness and the exposure. Exposure is that is a category A, B, C, and D. So it is assumed that the tower would be installed on a terrain with surface roughness and the exposure category of C. That is a town C and D. Okay, so category A means highly dense area. Category B means the crowded city, tall buildings are there. So that is why C and D are preferred for installing the wind turbine. So here it is given exposure A, category B, category C, and category D. Okay, so generally C and D are better for wind turbine installation. Then we have to calculate the velocity pressure exponent coefficient Kz. Okay, so here the values are given for different height for exposure C. So the velocity pressure coefficient for different heights can be referred from this table. Then there is another approach for computing this Kz, that is velocity pressure coefficient. Okay, so by considering the roughness height and reference height, and for particular height, you can find out the value of Kz by using this expression 2.01 into Z upon Zg, where Zg is the reference height and Z is the height at which you want to calculate this Kz value. And to the power 2 upon alpha, where alpha is the exponent which is considered for a different exposure B, C, D, okay, for a particular height. Then you have to consider the topographical factor, that is KZT. So if the hill area is there, though axisymmetrical hill or escarpment, which type of topography is there, so accordingly this KZT factor is calculated. Okay, so this KZT is equal to 1 when this H by LH. So here you can see H is the height of the hill and LH is the horizontal distance of the central axis of the hill to the uh, um, tower. So if that H is less than 15, then for exposure C and D, okay, then H is less than 60 for exposure B. So KZT is considered as a 1. And for escarpment, this KZT can be calculated by the expression 1 plus K1 K2 K3 whole square. Okay, where K1 K2 K3 that can be referred from this data. K1 multiplier, K2 multiplier, K3 multiplier for different H by LH ratio, and 2D reach, 2D is escarpment, and 3D axisymmetrical hill. So generally this KZT is taken as 1 with the assumption that flat region environment. If the flat region environment is there, then in that case KZT is considered as 1. But if the axisymmetrical hill or escarpment is there, then in that is you need to calculate it specially. Then value of C up, that is force coefficient, which were taken from figure 6.19 and 6.21 of the ASCE code, American Society of Civil Engineering. And these values are 1.2 for tower and 1.1 for wind turbine. So these values are directly given here. Okay. Now you have to see the gust factor. So gustiness actually it accounts for sudden rush of wind and structural damping, aerodynamic admittance gust correlation. So you have to calculate the gust factor. Okay. So for steeper building and steep structure, generally gust factor is taken as a 0.85, and for flexible building and other structure, you need to calculate it separately by rational analysis that incorporates the dynamic properties of main wind force resisting system. Then after calculating all these factors, the velocity pressure can be calculated. Velocity pressure QZ can be calculated at particular height. So by this expression, that is 0.00256 kz, where kz is the velocity pressure exponent, kzt is the topographic factor, kd is the directionality factor, v is the velocity of wind, and I is the importance factor. Then G, gust factor and force coefficient we'll consider later. Okay. So gust factor and velocity coefficient is considered here. That is to find out the total wind force which is acting on the nacelle part and on the tower. Okay. So this total wind force you can calculate by using this expression QZ into GCF, where G is the gust factor and CF is the velocity coefficient. Okay, and AF is the swept area. Okay,
Sir.
and the moment, yes, please.
Yeah, sorry for interrupting, but we are running out of time. So please, can you consolidate, wind up your presentation in next 5 minutes?
Sir. So in this way, force and the moment which is acting on the tower and the nacelle assembly can be calculated. Okay, and some other approaches are also there for newer design method, that is CFD, computational fluid dynamics, to model the tower shadow effect, and VMS, that is variable multi-scale method, and LIDAR, that is light detection and ranging, that is to provide feed forward and feedback controls for reduce fatigue in towers and energy maximization. So at last, we can conclude that more power output per turbine will mean building higher towers to access the higher wind speed, and higher towers will require new materials to be explored, and it means coming out of the comfort zone with respect to steel tubular tower, and materials like pre-stressed concrete, then ultra high performance concrete, then lattice structures can be used for enhancing the life of the tower and performance, and higher towers will require stiffer design instead of soft towers design at present. So this is all about the tower design, wind tower design. Actually very limited time was there. That is why I have explained it in a very short time. I have not elaborated it much. And if you have any queries regarding this, please feel free to ask me.
Thank you very much, sir, for such a nice talk. So panelists or the participant, if you have any question, maybe we can take one or two quick questions. Okay, so sir, let me just ask a simple, like a very brief question. So I think one of the criticism of this wind power farms usually come from, that noise. So what are the methods like, industry is employing to minimize that?
Yeah. Actually, two types of noise is there: aerodynamic noise and mechanical noise. So mechanical noise is because of the rotating parts, that is the blades, then the gearbox, then coupling, etc. So for reducing that mechanical noise, better lubrication and some enhanced designing parameters they can be chosen. And for aerodynamic, to reduce the aerodynamic noise, that is providing the proper blade shape, that aerofoil blade shape, then the optimizing the blade profile, so that can be done to reduce the aerodynamic noise.
Okay, thank you, sir. So, and just what is the time line of this? Life cycle of this wind power farm? Let's say we have large scale, 20, 30, 40. How many years does it go before we need to dismantle it and start afresh?
It can be means around 20 to 25 years.
Okay. Yeah. Okay, sir. Thank you very much for.
But maintenance part will be continuously carried out.
That would be their wear and tear that you need to
Yeah, yeah.
Okay, so I would like to thank you on the behalf of MPVS for such a nice talk. And now we have next speaker. I think Professor Vivekananda is waiting. So let me just briefly introduce Professor Vivekananda. Before that, I would request Lokanath to please shift Dr. Vivekananda into the panelist so that he can share his screen.
Already
So,
done, sir.
done. Okay, thank you. So Vivekananda is as a faculty member in MNIT Jaipur. He is also, was awarded one of the most prestigious fellowship awarded by the government of India, that is Ramalinga Swami Re-entry Fellow. He has also been awarded the grant from the Royal Society of Art and Sciences, University of Gothenburg, Sweden. He has ongoing research project, 5 in fact. And his major contribution is in the field of bio-renewable fuels by innovative bioconversion technologies. So his research basically ranges from bioprocessing, pre-treatment, enzymatic saccharification, and the characterization of biomass for enhancing bioenergy production. So he has been working he also worked as the senior postdoctoral research scientist in Sweden and Norway for 8 years, and he has published more than 75 international peer-reviewed research articles and more than 29 conference proceedings. So with that, I would invite Professor Vivekananda to share his screen and present his talk.
Thank you, Dr. Sunil, and the organizers for giving me opportunity to be here and share the knowledge. And thank you for the generous introduction, actually. And I also would like to thank Madhya Pradesh Vigyan Sammelan and Expo, MPVS-2021, IIT Indore, Madhya Pradesh Vigyan Sammelan Evam Pradarshini, Vigyana Bharati, for working together for the noble cause to celebrate Swatantrata Ka Amrit Mahotsav. So in the line of Renewable Energy Conclave, I think we have different speakers, very nice one from around the country with the different multidisciplinary subject areas. And today I will be talking more on the bioenergy area. So I'll just share the screen.
Right.
Is it visible now?
Yes, sir. It's visible.
Okay. And I am allotted 30 minutes or 40 minutes?
40 minutes. It's fine. You can take your time.
Okay, thank you. So the title, as Dr. Sunil has already introduced, Biorenewable Fuels by Innovative Bioconvergent Technologies. So let's see and try to understand, because we may have different, people over here as the audience as well as the participants from different academic origin. So I'll just try to briefly explain what is biomass and what is structure and all that stuff so that we all could sail in the same boat. So biomass, anything like from agricultural material, I'm talking from that point of view. It is made up of different types of plant cells. And then there is a cell wall, which is composed of a lot of microfibrils, and they are again composed of cellulose and hemicellulose, and they all are entangled with a layer of lignin so that biomass remains rigid, straight, and it can be saved from the pathogenic attack, etc. So lignin itself has a nature's glue. It works and keeps all those cellulosic fibers all together so that plant can stand erect. But this lignin, which is very good for the plants, may be bad for our own application, because human is a selfish animal. And then this lignin, it limits the hydrolysis of that cellulosic fibers, and then it makes the cellulosic fibers or all those polysaccharides less available for the process of hydrolysis, and thus it delays the fermentation and kind of much more lesser efficient bioconvergent process. So point is, let us do some technical interventions so that this lignin could be removed, and the cellulosic fibers, they are open and exposed for the microbial or enzymatic attack. Let us talk it in terms of civil engineering. Suppose there is a brick and it's called a monomer, and the wall itself is called polymer. So you have a brick that is monomer, and the wall itself is called polymer, that you can call cellulose, and then mortar, whatever you are putting in between, that is hemicellulose and lignin, that keeps all those monomeric brick units all together to make this wall very strong and erect and impermeable to the water, etc. Almost same analogous condition takes place in the plant cell, where all these glucose molecules, they are polymerized to make cellulose, and this lignin and hemicellulose, they are all together entangled and keep these cellulosic fibers stable and straight. Our job is to remove lignin so that these cellulosic polymeric units could be exposed to the microbes and enzymes, and so that these microbes or enzymes could hydrolyze the system, and then we may have this glucose as a free monomeric units, and these monomeric units can again be transformed with the help of enzymes, microbes, or chemical agents to get the product of our interest in here in terms of biogas. And in that case, what is the role of pre-treatment? So any kind of treatment or process that makes this hydrolysis much more efficient is called pre-treatment. Let's get an example of soaking the rajma or chole overnight so that it cooks fast in the next morning once you boil. So what happens is that water gets absorbed in that rajma or chole, and it enters into the cell wall of those seeds, and then it really becomes a bit swallowed. And once you apply high pressure and temperature in your pressure cooker, then all those cell walls, they get ruptured, and you have the soft chole or soft rajma. So it's just like that once you apply pre-treatment, so what you do in case of chole or rajma, that you try to minimize the cooking time because you have soaked it or pre-treated it with the water. The same goes here for the lignin also, that you can't remove the lignin directly, rather you have to give some kind of pre-treatment so that it gets softened, and once you have the right process in your plant, you can remove or degrade the lignin from the system. So what happens is here, this kind of pretreatment is of n types, like physical pretreatment, chemical pretreatment. There is a steam explosion, there is a ionic liquid pretreatment. There are n number of technologies for the pretreatment, which makes the biomass softer because it somehow degrades and removes lignin, and then the biomass is easily available for the process of fermentation. So you see here. You see here, there is cellulose, lignin, hemicellulose, and once you go for pre-treatment, all these lignin molecules are removed and you have cellulosic fibers available for the fermentation. So pre-treatment process disrupts the lignin structure, it facilitates the enzyme accessibility, reduces the crystallinity of the cellulose, and increases the overall surface area for enzymatic activities. And as I told you, this is of different types. Grinding, chipping, milling, this all increase the surface area, and they are like for short treatment time, reduces the crystallinity, but they use a lot of energy. Physicochemical steam explosion, AFEX, I mean ammonia fiber explosion, carbon dioxide explosion, ozonolysis, and wet oxidation. These all increase the surface area. They transform the lignin, as well as they also hydrolyze the hemicellulose, but at the cost, they generate inhibitory compounds which microbes don't like during the process of fermentation. So either you have to remove those inhibitors so that your process remains as efficient as possible, but you have to pay for this to removal, and it's a really expensive business. The third is like chemical, where we use a lot of alkali, acid, organic solvents, as well as ionic liquids, and it hydrolyzes the hemicellulose to xylose and other sugars, and it alters the lignin structure actually. And this process is again expensive, and there is a chance for a corrosion of the equipments we are using, and again there is a formation of toxic byproducts. And above all, you have to neutralize the system because you have used alkali, suppose sodium hydroxide, acid, suppose hydrochloric acid or sulfuric acid or nitric acid, etc. Some kind of organic solvents. And if you talk about ionic liquids, they are salts of the diazonium nitrogenous compounds, and they are really, really expensive, although they are like kind of recyclables. You can use it in different cycles in the retreatment process. But again, that is, commercially less viable. So point is, why don't we think about the use of fungi, which is a natural lignin decomposer in the nature? I'm sure we all have seen wooden logs lying nearby the pond, and there is some kind of mushroom growing on it. So how does the mushroom grows on a wooden log? It just secretes enzyme, and that enzyme hydrolyzes the system, the lignin, the cellulose, the hemicellulose into that wooden log which is present. And then it takes the carbon as a food from that wooden log and it grows. And in that lignolytic enzyme system, there are three types of enzymes: lactase, lignin peroxidase, and manganese peroxidase. So lactase is kind of multi-copper enzyme that oxidizes phenolic units of the lignin. Lignin peroxidase, that is also called LIP. It is a heme protein and oxidizes non-phenolic structures of lignin, because lignin is heterogeneous polymer where you have aliphatic as well as aromatic polymers bind together with different types of ether, ester, and hormonal group of functional groups which are present, and it's really, really difficult to degrade, and it's a recalcitrant material actually. And manganese peroxidate, it oxidizes Mn2 plus ion to Mn3, and this Mn3 oxidizes rather phenolic and non-phenolic, both the structures in the lignin. So you have all these three enzymes. There is one which is manganese peroxidase, which can act vis-a-vis with the help of lignin peroxidase. But this guy, lactase, it can even work on its own. That is the beauty of the lactase enzyme present in the lignin system. So what we found, like since all these pre-treatment technologies, be it a physical, chemical, or physico-chemical, they have kind of disorder advantages and advantages. Then why should not we go for some kind of biological pre-treatment where we use fungi, the natural enzyme, which can degrade the lignin present in the agricultural biomass, suppose straw. Now the point is, why not use it directly in the system? Although this process is a little bit slow compared to the chemical or physical pre-treatment, but we found like there is a dearth of efficient process of employing fungi for removing recalcitrants in biomass by determining optimal pre-treatment conditions. So what it will do, it will soften the biomass by degrading the lignin. And then there is a scarcity of research regarding efficient management of fungal mycelia left in the biomass after biological pre-treatment. Let us take the example that you are growing a lot of fungi on the wheat straw. And if you are chopping down straw, and then there is a digestion of this wheat straw, but still there's a lot of fungal mycelia which may choke the bioreactor while it produces biogas. And it will not be utilized by the microbial community present as a biogas slurry in the plant, in the bioreactor or biogas plant. So point was what to do with that mycelia, because it will keep on, collecting in the system, and then it will be a challenge to remove this. Okay, then we were thinking, why not to use some kind of chitinolytic bacteria, because fungal cell wall is made up of chitin, and then this bacteria can even digest the fungal cell wall, which is made up of chitin, and we can even get from that carbon which that comes after the degradation, we can get the biogas coming out from that carbon also. So point is that once you have the only one untreated material from where the biogas is going to be produced, you have a pre-treated material with fungi, I mean the straw and fungi, and then you have a third group where you have fungi, straw, as well as bacteria, which will digest the fungal mycelia also once it degrades the lignin, so that you have more and more biogas production compared to the untreated one. So this was the overall thinking behind these experiments. And you see here, these upper ones, the green, these things, they show 14 days, 28 days, and 42 days. They are untreated material, and then you can feel about here in the bottles that there are some kind of mycelia, that woody cottony mass you can see it coming in the bottles. Again here from the different side views, and you see here this green one in the petri dishes, they are like the same yellowish because they have been treated, or just same amount of water was given, and here water and fungi was given. So you see there is a degradation of lignin, and the color of the straw has really been changed to brown. And then again, these were analyzed not only with the help of eyes, but even the biochemical characterization, and a lot of analysis was done. So you see there is a fungi called PO for Pleurotus austriatus, CG. It's a carbonally globosporum, which has been isolated from the desert of Jaisalmer as well as Bikaner because they are thermophilic in nature. So after 14 days, there was a very little reducing sugar coming out from the Pleurotus austriatus. But if you look around here, 28 days and 48 days, then it's a lot of sugar coming out from the Pleurotus austriatus. This was case of wheat straw. This is the case of pearl millet straw because Rajasthan, pearl millet is the bajra. And Rajasthan is the top one state in the country which produces maximum amount of bajra. And for you who don't know, bajra has the maximum iron content into it. And you don't find any male or female in the desert districts of Rajasthan who are anemic or they have less hemoglobin because they mainly eat chapati from the bajra, khichdi from the bajra, and it is one of the richest source of iron. There are availability of pearl millet cookies, pearl millet khichdi, pearl millet chapati, pearl millet mixtures, and it's very nutritious actually. And then we also saw like this is the pearl millet straw, this is wheat straw. So there is a lot of sugar production or hydrolysis of the reducing sugar, which is measurable. The same goes here for the globosporum. You see here again 3.5. So I mean, it's a significant amount of increase in the production of reducing sugar. So that indirectly says that there is hydrolysis going on in the pre-treated samples with these fungi. This is the kind of scanning electron microscope, microscopic images at different magnifications. So this is one which looks like more cemented, untreated one. This is after 14 days, this is 28 days, this is 42 days for the wheat straw because they have been pre-treated with Pleurotus austriatus, one of the fungi. So you see those kind of disassembly of the cell wall actually. You can see this untreated one looks like more cemented. This is pearl millet straw, the lower 4 pictures, and upper 4 pictures they are wheat straw. So you see like there is a disassembly of the cell wall or the surface of the cellulosic fibers. Like it has a lot of cuts and nicks, but this untreated looks more cemented. So also it indirectly tells that there is a lot of enzyme production and fungal mycelia has penetrated into the straw from where it has got its sugar or carbon as a food source and secreted the enzyme to the lignin. So these are the especially areas where the attack has been done. So this is the scanning electron micrograph of globosporum. That's another fungi as well as luneta. You see the untreated and treated, they are more cemented. But again, once you look around these areas where it has attacked nicely, you can see there is a lot of degradation and brokerage of the wheat as well as pearl millet. Fourier transformed infrared spectroscopy was also performed for characterization. And if you see here, wheat straw untreated, here this black line in the left picture, it has a lot of peaks and very prominent ones. But after 42 days, you see the pink one here, the dotted, the topmost one, it has lesser intensity of peaks. And then few peaks have even been disappeared from it. So this is CO, C double bond C, carbonyl group, and then CH group. So these, you see, CH is even after almost disappeared, CO almost disappeared. CC, it's a little bit, and CO, it's also, the intensity has gone down. The same goes for the, here, it's a pearl millet straw. So it means like those functional groups which are present in the lignin, because it is aromatic as well as aliphatic, after the pre-treatment, they are going to be minimized and their intensity is coming low and low. It means they are disappearing from the system. And the same was done for the globosporum as well as lunata species. And again, you see this, the black one in the left figure, the black one is the wheat straw untreated. And then red one again, wheat straw treated. Permeatistra untreated in blue as well as Permeatistra treated in the green. The same goes here, and you see there is a lot of flattening of the curve and intensity has gone really, really down. So it indirectly tells that there is a loss of groups, functional groups, which are present in the lignin in untreated, and they are not or less present in the biologically pre-treated distra with the help of these fungi. So, and then there was a analysis called thermogravimetric analysis. It was performed, and then you see which is untreated. It has much more, temperature. But once the lignin is removed, you see here after the 42 days, the blue color, the temperature has really shifted towards the lower because the lignin has higher temperature for the ignition. The same goes here for the disappearance. You see weight loss, percentage weight loss. What you do? So the black, I mean the untreated one, it takes more time as well as percentage loss. But the treated one, it disappears fast because lignin has been already removed by the system with the help of enzymes. So the same, goes for the Globosporum organism also. And then the crystallinity analysis was also performed with the help of X-ray diffraction. And then again we see like there is a lessening of the cellulose crystallinity. It becomes more amorphous once it's treated with the different types of enzyme system. The same goes here. And then once the numbers were analyzed, the percentage crystallinity untreated, Vitistra, it has 68 percentage of the crystallinity, and then treated for 14 days 65, treated for 28 days 65 percentage, and treated for 48. So it has come down from 68, that is untreated Vitistra's crystallinity, to the 64. And then the same goes for the biomass, which is Permeatistra, the PMS, with the help of Pleurotus austriatus, one of the organisms, from 67 to 60. So there is a decrease in the crystallinity percentage of 4% in the Vitistra as well as 7% in the Permeatistra after the treatment with the Pleurotus austriatus. The same goes here with the help of Globosporum as well as the Lunata, which were isolated microbes, that it decreases from 68 to 63 for the Vitistra, and the Permeatistra decreases from crystallinity percentage of 67 to the 64. It means it has been really working very nice to remove the lignin from the system. Then the chemical composition analysis of the different types of estra, which has been treated with the different organisms, was also performed. And you see here, the untreated estra has a lignin percentage of 17%, and mainly lignin. So, and there is a hemicellulose and cellulose also. And then there is a lignin degradation percentage. So you see untreated, it's 17%. With estra, when it was treated for 14 days with the Pleurotus austriatus, it has around 15% lignin, so 2% was degraded kind of thing. And then 28 days, it says around 11. And then after 42 days, only 10% of lignin was there. Rest 7% was degraded with the help of fungi. The same goes over here for the Permeatistra with the Pleurotus austriatus. So it says around 11% presence of lignin, so 6% have already been degraded. Globosporum, once it was treated, then Vitistra, it was only 10% lignin remaining. Rest 7 was degraded, and for the Permeatistra, I think it was more than 7%. 10, I think it's more than 10% which was degraded, 9 to 10%. And for the Lunata also, a very significant amount of lignin was degraded with the help of these two organisms. So it means the Globosporum as well as Lunata, they degrade around 45 to 48% lignin, and in a very significant percentage, and then try to make the biomass more soft, as well as accessibility of the cellulose also gets increased by this kind of treatment. And then the time was like, okay, if our system of fungal pre-treatment is working, and now try to get some bacteria with a lot of screening experiments so that you have a very nice strain coming out, which secretes a lot of chitolytic enzyme, chitinase, which can degrade the chitin, and then this fungal biomass could also be digested. So these were isolated with the help of pure culture method on the Petri plates, what you are seeing here. So this is the control after 24 hours. This is the control after 48 hours. In the upper right picture, you can see this cottony woolly mass of the fungal mycelia, which is growing around. And then in the test samples, there was a streaking of this bacteria along this fungi. And then you see this fungal disc in the, I'm talking about the lower left picture. You see there is a fungal disc and the arrow red head. But this fungal disc is just like that. And even after 48 hours, now I'm talking about the bottom right picture, the Petri plate. There is no growth of this fungi because this bacteria has the chitinase activity. And by the time mycelia is growing, this bacteria secretes the enzyme and it eats or chops down or hydrolyzes that fungal mycelia. And that's why this fungi is not growing. And then we try to, so this was more kind of qualitative analysis. And here is the bar chart shows you the quantitative analysis, like how much enzyme activity was prevented. So the chitinose activity was detected in two of the strains, CB1 and CB2. And CB1 was having around 70 IU per ml of the chitinase activity. And CB2 was showing only 53.5 IU per ml of chitinase activity. So in that case, CB1 was selected, although there were a number of bacteria which were producing chitinase activity, but the potent one, the two what I have just shown. So this is the comparison of fungal treatment and its impact on biogas yield. So now what I'm trying to say, like in one hand we have the fungi which is working very nicely to degrade the lignin. In another hand we have the pure bacteria in hand which degrades the chitin. Now what we will do, and we will try to analyze here, what is the impact of fungal pretreatment if we apply fungi, what kind of difference it creates in enhancement of biogas production compared to the only untreated straw. I'm not talking right now for the bacteria, but only fungal pretreatment. So in the left picture, so the blue color indicates the biogas overall, and red color indicates the methane. And methane is usually, it's in the range of 60 to 65% of the biogas, because biogas is a mainly mixture of methane and carbon dioxide. So they hang around in somewhere in the 60-40 ratio or 65-35 ratio. So I will talk in terms of suppose biogas. So biogas yield from the untreated wheat straw, WS, is around 437 milliliter per gram of volatile salt. And once it was treated with Pleurotus austriatus, the biogas yield increased up to 529 milliliter of volatile per gram of volatile solid. And once it was treated with these two of the isolated organisms, Globosporum and Lunata, then biogas has increased up to 567 as well as 533 milliliter per gram of volatile solid from the wheat straw. And same goes for the pearl millet straw. So untreated pearl millet straw had the potential of 324 milliliters for the biogas production. And once it was treated with Globosporum, CG and CL, the Lunata, it increased around 543 and 462. So there is a significant milliliter which has increased in the volume of the biogas production after the fungal treatment. So, and then we tried to see what will happen once we add the bacteria in the system. So what we did here, like we took the untreated wheat straw that we have already seen. We used it as a control, just putting some water. We used fungi as well as wheat straw, our single step pretreatment. And then in double step, what we did, WS plus F means fungi plus CB means catalytic bacteria. On the 0 day, 0 day in the sense we put catalytic bacteria, fungi, and wheat straw all at the same time in the same class. But for the wheat straw, F plus CB 21 day, it means we waited for 21 days till the fungi grows and degrades the lignin, And once it has a lot of mycelia, then on the 21st day, we inoculated the bioreactor with this bacterial culture so that this bacterial culture can eat out or chop down the fungal mycelia. Because we just wanted to test what will happen if we put this bacteria on even 0. So you see here, this green one is the top one most. It has produced highest biogas production, and the red one is the untreated one, and the blue one, once we put it, so it has not a very significant impact. The same goes for the permanent straws. This is kind of a bioreactor setup, how we do it in the batch fermentation system, although we also run CSTRs. But this is just to showcase you how we analyze the system. So this is the biogas biomethane potential test system, where you have these bottles, and in that case, you see this biogas slurry put inside and a straw as well as bacteria. They are packed with the help of butyl rubber. It's like a early glucose bottles in the hospital, and then it is nicely sealed and packed and flushed with nitrogen so that you remove any oxygen, and then you can totally create an aerobic system over there. So this volume, which is the water volume, and then upper, that is called headspace volume. So you have pressure transducer. So it reads the pressure in millibars, and then you note down that. Then you have the gas chromatograph system, where you take the sample from this headspace in the syringe, you inject it into the gas chromatograph system, you get the percentage of methane and CO2. You know the volume of these bottles, you know the temperature, pressure, you know the volume of liquid in the system. You just apply PV is equal to nRT, you have the biogas volume, and once you multiply it with the percentage, you have the volume of the methane getting produced in the system. So once we have this, the one-step pretreatment, I mean the wheat straw plus fungi, and two-step pretreatment, wheat straw plus fungi plus cadmium bacteria. So you see here on the 21st day, compared to the untreated wheat straw, which is around 432 milliliter of biogas. Once we pre-treat it with fungi as well as treat with bacteria, the production level of biogas goes from 432 to 609 milliliters per gram of volatile solid. This is in the case of wheat straw, and it also increased from 371 to 582 in terms of per milliliter straw. Once we have added fungi as well as bacteria after 21 days. Same goes with the lunata species of the fungi. It has increased from 449 to 574 in the wheat straw, and it has increased from 360 to 516 for the permanent straw. So there is a significant level of enhancement in the biogas production with the help of these two isolated fungi. Then we also went for the energy and economic analysis. I will not go into the too much detail, but I will just tell you the numbers, like biogas production potential with the help of Pleurotus, Globosporum, as well as Lunata is much more, because the blue ones indicates the untreated, and orange lines are bars, they indicate the treated one. So you see that how much is the difference once you pre-treat it. Even in energy potential, in terms of kilowatt hour, Globosporum has potential to increase it by 41%. And then there is a cost saving in INR. Again, the Globosporum has potential to save around 41%, because if you treat it, you get more and more gas. And then greenhouse gas emission saving per kilogram of CO2, it's much more in the Globosporum. And these all calculations have been done for 10,000 kilo of wheat straw. So we just projected the study, like how much will be the potential if we go for a higher scale or pilot scale. And this paper has been very well accepted in the Journal of Clean Air Production, and there have been a lot of references and requests for sharing the paper. And then again, you have biogas potential for the per millet straw. That was for wheat straw. This is for the per millet. So you have again very significant level of difference compared to the treated and untreated one. And this was again done for the 10,000 kilogram of per millet straw. These are the CSTR, lab scale CSTR 20 liters experiments. So we were using these things in the duplicate one or the control one with the test one. So they have all been running very nicely with the working volume of 12 liters and temperature plus minus 38 degrees, HRT for 25 days. And we run like 3 HRTs as a duplicate, and organic loading rate was 3 gram volatile solid per liter per day. And with the help of this Tedler bags, we try to collect the gas either into this, or once it is full or it's not available, we try to measure the gas volume with the help of water displacement method. So we use both of the things for the water displacement method as well as the Tedler bags, and we calculate the volume from this CSTR. Again, we take the gas in the syringes and we go for its gas chromatographic analysis that's available in our lab, and we determine the percentage of methane and CO2 in the system, and then we get the value of the methane coming out from the system. So this is the outcomes in the CSTR in terms of biogas, methane percentage, COD removal, ammonia, as well as alternative. So it was one of the very detailed studies, and all these papers have really been published in many indexed journals with a lot of good inputs from the reviewer and editor. The point is that system was very nicely working. There is a lot of decrease in the COD system. Then there is ammonia, which was in a very good limit of the system. It was fine. It was not harming. And then there was a good methane percentage, because commercially the quality of biogas depends on the percentage of methane instead of percentage of CO2. And then we also performed microbial community analysis. I will not go into much detail. And then we found like there were a few genera which were really dominant. And this is untreated for 14 days, 42 days, and 70 days, because we worked up to 3 HRTs, 3 hydraulic retention time for 25 days. So this is in between of the first HRT. This is in between the second HRT, and this is somewhere around the end of the society. So you can see like how the microbial community have been shifting, which were present on the 14th day till the presence on the 70th. The same goes here for the treated one. The TR means treated one. The same day samples are there, so there is a lot of good synergy. But you see, like who is there and who has been disappearing from the system, depending on the type of carbon source available as a food in the CSTR. So there is a lot of microbial community dynamics which have been noted, and it has been reported in the papers why it has happened, because some are acclimatized, some are not. Some are liking the overall micro environment, and some are really very sensitive to that. So that's why there is a lot of shift in the microbial communities present into the biogas digester. So the conclusions of the study, it was like among the isolated strain, the Globosporum revealed highest lignolytic activity, followed by Lunata. Significant differences in structure and composition was observed after pretreatment. You have seen that results supported by the SCM analysis as well as the biochemical analysis of reducing sugars presence, as well as the FTIR data, thermogravimetric analysis, as well as X-ray diffraction analysis. Highest lignin removal of around 45 and 48%. After the pretreatment of wheat straw and palmillet straw was detected respectively by the Globosporum, and then the coupled pretreatment of this Globosporum and chitinolytic bacteria resulted in 41 and 57% increase in overall biogas yield from wheat straw as well as palmillet straw compared to the untreated wheat straw or palmillet straw under the batch anaerobic digestion system. Pretreated wheat straw with the help of Globosporum combined with chitinolytic bacteria, which was added on the 21st day during anaerobic digestion, revealed around 16% higher biogas yield in CSTR, not in batch. Batch it was around 41%, but in CSTR, once you go at a higher level, there is different kinds of losses. So that's why the production has little bit decreased in the terms of percentage compared to the untreated wheat straw. And in comparison to the batch scale, the average daily bagasse yield for pre-treated wheat straw and bio-augmented with the carotene bacteria was 3.7 folds higher than the untreated wheat straw. So that was the beauty of the overall system. Like this much increase has been achieved. The overall uniqueness of the system that you don't need to neutralize because there is no chemical involved, so you don't need to neutralize the pH. Your reactor really goes, stable for. We have tested it around like 6 to 9 HRTs, and it has been stable. And the data was published because she was a PhD student. The girl was working on that, and it has been published very good journals. And then again, we have tested it, so it has been stable. And then there is a lot of dynamics in the community depending on the type of carbon source available in this reactor. And then it goes stable because you are running the same system. So, but initially it has a kind of turbulence in the microbial community dynamics. But slowly the people who like it, or the microbes who like it, they stay. And this slowly they disappear. So I would like to thank you, Material Research Center at the MNIT Jaipur, TP3, IARI New Delhi for identification. Organizers to invite me for sharing the knowledge here. I would like to welcome if there are any questions, please.
Thank you, Dr. Vivekananda. It was very, very good talk. I'm sure everyone find it very knowledgeable, and they must have learned something. I think I'm losing signal. Can you hear me?
Are there any questions, sir?
Yeah. Actually, I think I'm losing connection in between.
Okay.
So, right. So, participant or audience member, any questions that you wish to ask from Dr. Vivekananda? Okay, if there are no questions, so, sir, may I ask a couple of questions?
Please go ahead.
Yeah, so I saw like in your slide number 18, you have mentioned about different kind of I think polymers that you are getting, the cellulose and hemicellulose, and I think it was lignin, and you are sort of quantifying it.
Yes.
Like how much is remaining. So what is the technique that we are using to quantify it?
There are two different techniques. One is at a larger scale, we do it in our laboratory itself, that is called biochemical analysis. So you have different types of protocols that how much time you have to soak it in acid, how much time you have to centrifuge it.
Okay. Hello. Lokanath, I'm losing connection. Do you have the connection?
Yes, sir. Sir, I guess the problem is from Dr. Vivekananda side, sir.
No. I think problem is my side. I can see sometimes this IITI is going out to this 2.4G. 5G is coming, and then this is going. I think it's accelerating. Vivekananda, sir, can you hear me? No, I think we lost him.
Hello? Are you there? Yes.
Yeah. We are here, but I think we lost you. So you are mentioning that you have in lab 2 technique, you are doing centrifuge, and then you are able to.
Yeah. So one is this biochemical technique, which can be done in the lab itself. Another one is the high pressure liquid chromatography technique. So, so even we can do with that also. So running the standards for the lignin and hemicellulose, and for this lignin also we can also go for gravimetric analysis, because once you remove cellulose and you remove hemicellulose, then what is left is the lignin as well as the ash content. So for that also there are protocols.
Okay, so we know that at what temperature they sort of burnt out. And
yes.
Okay. No, because of what I thought, like, the chemical analysis was written, and if you look at the structure, they are, very, very similar. So it's very difficult to distinguish, and most of them are like semi-crystalline, so their XRD will look same.
Yeah.
If they're highly crystalline, we can do, but yeah. So that's very interesting. I mean, I didn't know that there are biochemical methods available for.
There are biochemical methods which are very exclusive for that particular group of oligosaccharides, as well as you have the different standards for HPLC. So once you have the standards, whatever you need to want in the HPLC, and then you can run this after hydrolysis in the HPLC, then you get the peak, and then you calculate the area, and then it gives you how much concentration of the sugar is there.
So, I mean, the second sort of query I had was, again, I think we had some discussion on that earlier. So, can it be scaled up? Because as of now, this burning of straw, wheat straw, or, this rice straw, it's a big political issue. And
Yes.
So can it, whatever we are showing, this much biogas be generated from this, is it scalable? Can we implement into the rural areas?
Yes, actually, the thing is we have been testing it, but we have to leave it half the way because of all this corona, the travel and all that stuff, because we were involved very seriously last year, last year rather, in getting this fixed. But we were just half of the day. I think the farmer and the family who were involved with us, they were like maybe they are done up to 20-25% of the job by the time this lockdown is starting. But we will be back it on soon, and we have tested it in the 20 liters of the CSTRs, and this has been done for the many like 9 to 10 HRTs. So only 3 HRTs that result I showed, but we have studied in the 20 liters up to 10 HRTs. That has been studied. So I think that will be tested soon.
Okay, so it has a lot of promise then.
Yes,
it has to be very, very good. And just a quick query, it's just for my own sort of curiosity, I would say that if we see that millet, especially I'm from a village, so I have seen bajra. I'm from Haryana.
Okay.
So is it even from looking through your sort of slide? So I see it is very. It seems compared to, let's say, wheat straw or the rice straw, it's difficult to decompose sort of thing, right?
Yes.
I mean, even strength wise also, I think it is a bit hard. So is it one-to-one relation with that, or it is something else?
You said last one, which relation you said?
I mean, because in your slides, if I see that whatever yield you are getting for this millet, it is lower.
Yeah.
And physically, if you see, this is a bit more hard or stiff, I would say, the straw of the millet.
Yes.
So is there any one-to-one correlation with that? Because I know mechanical.
I think that is more because of the climatic conditions as well as the type of lignin bonding and presence of different percentage permutation and combination of the aromatic as well as aliphatic units in the lignin of pearl millet straw.
Okay.
And that is also because of the nature or the climatic conditions present in the Rajasthan. So I think the bajra needs to survive and protect the soft material inside into it.
Okay.
So that's why if you see आप बाजरा खाते होंगे तो उसको बाजरे को कूटा जाता है ना?
Right.
ऊपर का छिलका निकाला जाता है. So
right.
It's easily digested. So I think it's because of the nature. So one-to-one relation is there because the bajra has to protect itself also for its own survival and.
Just a final on the same note, we know that the flour of bajra, especially, it gets spoiled very bad within a couple of, I think, week. People don't use it; they prepare it fresh and then they eat it, and that is because I think iron get oxidized. So I was under the impression that probably only the the grain only have this excess sort of iron. Does even the stalk or the straw also have the iron in that?
We have honestly not tested the straw for any metal content.
Okay.
So I'm sorry, but that's a good idea. I think I will ask the students to analyze and maybe
No, I mean, I was thinking maybe it is something different. I thought anyway we were mentioning regarding the different yields, so probably the chemical composition itself could be slightly different.
Yeah, so we have not analyzed the metal content, but we should. Yeah.
Okay. So that's from my end. So any other questions? I think Dr. Sanjay Singh is here. Ajay is here, I suppose.
Okay.
Yeah. Am I audible?
Yes, sir. You are audible.
Please.
Dr. Vivekanand, nice talk. We are also working biomass transformation. One of the thing like you mentioned lignin removal. So what you do with lignin? It is come out as a waste or?
No, I think, sir, there's overall lignin what is getting degraded in the system. So we have not removed it because with the help of enzyme of the fungi, I think they transform the lignin and then they somehow make it hydrolyzable by breaking the carbonyl or ester or ether bonds between the aromatic as well as aliphatic compounds. So we have not been able to separate it. Although lignin has a lot of commercial value, if we could get, so we have not been able to separate it because that's entirely different kind of project. And especially this agricultural extra, they have around 15 to 18%, I think, at large in the range, the percentage of lignin.
Because we are working on this hydrogenation of lignin components.
Okay.
So converting into aliphatic cyclic
compounds, yeah. In fact, there is a company in the Norway, so they extract vanillin from the lignin. As well as there is a lot of use of this lignin in case of agriculture also, because then all those weedicides on all others, they can be taken along with lignin so that it remains because of its weight and the hydrophilic nature. It's some of the components, not all as a whole lignin. As well as it has been used in terms of road construction because it has a lot of good binding property. So yeah, that is there.
Thank you.
Thank you, sir. Thank you.
Okay, so any other question from participant or the audience? No. Okay, if no further questions, then Vivekananda sir, thank you very much. And I thank you not just on my behalf, on the behalf of the MPVS organizing team, as well as the coordinators for this renewable energy conclave for such a nice talk. I think we have some panel discussion. So Dr. Ajay is joining in a bit.
Okay.
So if you have time, you please try to join it.
Sure. I'll just take a while and then I'll be back.
Sure. Okay. Thank you very much.
Thank all the organizers for this noble cause and wish you all the very best for the rest of the days. Thank you so much. Thank you.
Thank you. So we will convene maybe in 5 or 10 minutes. Let Dr. Ajay join, and then probably we could have a bit of discussion on the panel on renewable energy sector in Madhya Pradesh. Yes, Lokanath, maybe you can put a ticker or whatever you are writing.
Yes, sir.
We will join in 10 minutes. I just called Ajay, he's joining soon. Anyway, I'll be here, so you let me know any point of time we are ready with that.
हाँ मेंबर भी नहीं है जो हेड थे वो वहां से लौटे अपने पूर्ति है मेंबर भी
अंकल का अंकल
कौन सा अंकल को?
बना दिए या बन गया क्या
जब सर्विसिंग में है ना सारा
ऐसा देखिए और
लोग
चोरी करने से
तो देखो अगर ठीक
Hello.
Yes, Ajay. I think Dr. Vivekananda.
Sunil ji,
Yes.
just give me 1 minute. Let me put in.
Yeah. I'm just getting water. I'm joining in 1 minute.
Hello. Am I audible? Hello.
Yes, yes.
So sorry, actually, I just on the way, just going to SGIT. So
Okay.
if we are not able to connect with other speaker, I think now we can close this session now, right?
Okay.
So, hello.
Yes, yes, Ajay.
Uh, so I think officially let thanks to all the invited speakers, and first of all, we should thanks to Professor Chetan Solanki. He accepted our invitation and joined us today morning, and given a very good talk. And then due to some connectivity issue, we could not join Professor Prasant from NIT Bhopal, but later on he joined after lunch. So we also thanks to him, and we are very thankful to our colleague, Professor Sanjay Kumar Singh. He was always there in with us in our pre-event also, and today also he spent a lot of time, and he was with us from morning. So thank you, Professor Sanjay, for joining us and giving your time. And again, we are having Professor Vivekanand from MNIT Jaipur. And he was also the part of our previous event and panel discussion today. Again, he was with us. So Vivekji, thank you very much.
Thank you, sir. Thank you all.
So due to some issues, we are not able to run this panel discussion. Hopefully, in some other meeting, we will conduct it.
Paka.
And also with all other member, Devenji was with us from LNT. And but due to some engagement, actually, he has to left 2:30. So maybe some other time in some other event, we will connect with him also so that we can get some more time for interaction. So therefore, we just lose 2 panel members. And others, Dr. Sunil is with us, our team, Dr. Pakshira, and there are several students was there who worked with, I think, last 1 or 2 months to plan these activities. And our other members, we also thanks basically the MPVS team who has given us the support, and all others who has given the support and wishes for this event. And now I request Sunil ji to please proceed, and I think we can close the event. Sunil ji, please.
Yeah, so again, on the behalf of our, the team, I also thank all the audience members as well as the participant students sitting here who are attending online as well as who are watching on YouTube for, giving their time and having, listening to these fascinating talks. I'm sure all of you must have learned, few things about different aspects of renewable energies. With that, I think we can close the session. Once again, I would like to thank all of you for your time, your effort preparing these talks and giving us nice talk. I think some of these talks are at very short notice also. So with that, I think we can close the session. Is it okay?
Yes, thank you everyone. Thank you. And Loknath, please close the sessions.
Yes, sir.
And also the YouTube. Okay, thank you everyone. Bye.